right? So I'll say control enter, right? So it says affected rows 1. That means it has inserted one row. Now, instead of inner join, if I do left join, now what exactly left join will do? Student ID 1 has taken course 102, right? Now if you see from here, 101 course is taken by student 1 as well as 101 course is taken by student 2. So one student can take multiple courses. This curly braces defines the JSON data type, right? So what I will say name, right, colon, I will say Jane, right? This is one key value pair, then comma, age, right? So I will run this one. And if you see, all of them have Node.js keywords in title and content fields, right? So this is what full text search helps us in doing. It will help us in finding the content which matches a particular keyword. Hello friends, I want to welcome you to my course on MySQL database. So I have made this course for developers who want to learn about MySQL database and those who want to work on backend. Learning of database and database management system is very important. So this course is catered for them. So if you are looking for a course on database certification or database administration or data analysis, then probably this course is not right for you. This course is specifically designed for developers because I myself am a developer and I have developed this course by putting all my learning, all my experience, all my ups and downs that I have endured during my 9 years of experience in this software realm, right? So I hope this course will help you, right? This course is specifically on MySQL database or no relational database. This course does not target the NoSQL database like MongoDB and those kind of stuff. This is pure relational database, right? So whatever you will learn, these are relational database concept. I have taken MySQL here as the example. Now, learning of database is extremely important, right? Database constitutes the backbone of any software company or any company for that matter, right? They say data is the new oil, right? If you don't have understanding about how database internally works, right? How to write queries, how to create or organize your data, its schema, then it's very difficult to survive in software industry, right? It's very crucial for you to understand the database, its management system, right, and all the concept that is related to the database, right? That's what makes a seasoned software engineer, specifically a backend software engineer, right? If you are looking to go into backend software development, then understanding of database is extremely important, right? So this is what the course is designed for. We will start from absolute zero as if you are a beginner, and slowly we'll keep on taking up a notch, and we'll go towards advanced concept. This course will be mostly hands-on. There are one or two places where I'll be using little bit of PowerPoint to explain the concept, but otherwise this course is extremely hands-on. I'll be writing the query and I'll be running the query, and I'll give you the live example of how the query is written and how its output will be structured, right? Now, in order to take this course, what you need, of course, you need a MySQL database instance, right? There are a couple of ways in which you can get the database instance. One is using a cloud service provider, right? You can go to any cloud service provider like Amazon AWS. From there, you can take a MySQL instance. All you have to do is you should know the URL or the host name of the SQL database, its port number, and its user ID and password that you need to connect, right? If you have this information at hand, then you can proceed with the course. Alternatively, what you can do is you can install a MySQL server engine on your local system, right? It is available for both Mac and OS operating system. If you go to the MySQL website, there is a community edition that if you install, right, that you should be able to install in your system, and with that it will run as a local host. It will run on a port number, and ID and password you can configure during installation. There is another method, that is using Docker, right? So what you can do is you can write a Docker compose file. I'll show you my Docker compose file, right? So if you don't know Docker, that's fine. If you know Docker, you can see this one. This is a Docker compose file. What this will do is this will take a MySQL image, right? I have named it as Docker MySQL, right? And its password is, of course, password I have kept it. Of course, if you want, you can change it, right? And by default, the Docker username will be root, right? And it is running on port 3306, and inside the container and outside the container, it is pointing to same port 3306. Right now, if you run Docker Compose up, right, like how I have done here, you will get a running instance of the Docker, right? So these are the three options. I leave up to you what option you prefer the best, right? For me, I'm going to use the Docker Compose because that's what I feel convenient, right? So I'll be using the Docker Compose method. Of course, if you want, you can go for a cloud instance, or if you want, if you feel convenient, you can install the MySQL database server instance in your system. Now, how to connect to the database, right? So there is a tool called MySQL Workbench, right? So there is a tool called MySQL Workbench, right? So if you open that tool, it will help you connect into the database, right? So here what you can do is you can add a new connection, right? You can give a connection name. You can give any name to this one, right? Here you have to give the host name, right? Whatever is your host name. For me, it is the localhost or the loopback IP address. For you, if you have taken it from a cloud service provider, from their console, you can get the host name, right? This is the port. This is the username root, and you have to give a password, right? With that, you should be able to connect, right? You will get this kind of a icon, and with that, you should be able to connect into the database, right? So for me, what I'm going to use is a VS Code extension, right? So what this VS Code extension is, this is MySQL extension, right? So I'll enable this one. For you, you might have to do an installation, right? Once that is done, you will get this kind of a icon here on your VS Code, right? So what you can do is create a connection, right? Then select the MySQL, right? Here you have to add the host name. Here you have to give your port, right? Username and password, right? With that, you should be able to connect, right? So password, right? Now what I will do is I'll try to connect, right? If you see here, it has connected, right? Now if I scroll down this one, I have some database. So what you can do is I already have a database called learning. If you want, you can create your own database. So within one database, we will create multiple tables, and within that we will run all our queries and we will learn, right? So I have created a database called learning. If you want, you can create one more database here, right? Create database, right? YouTube MySQL masterclass, right? And what you have to do here, if you see, there is one execute button, right? You can either use this one, or what you can do, if wherever is the cursor, right? This wherever we have this semicolon, right? Just put your cursor there and press Control Enter, right? Your database will be created, or this query will be executed, right? Here your database is created, right? So create database with your whatever name you want to create. Once that is done, you are all set to deep dive into this course, right? So I'll see you in the next video, and from the next video onwards, we'll start learning the database concepts. Now let us start our discussion from tables. Like, what are tables? So if you see, tables are actually the building block of the database, right? Every database is nothing but collection of tables, right? Tables and relationship within the tables. That's what constitute a database, right? And now, what is a table? We all know table is basically a collection of rows and columns, right? So here, if you see, I have taken a dummy example. So I have called this table as employees table, right? If you see, it has few columns, right? Like ID, name, designation, and salary, right? This is what a table is, right? And within each column we have few entries, right? Like, for example, right? And for each column we have certain rows, right? So for row 1 we have id1, there is a particular name, right, and it has a particular designation, and it has a value of salary, right? And yeah, it's not always mandatory to have all the values with us, right? Some value can be empty, which is represented by null in database, right? So if you see for row number 2 we don't have a value for salary, and for row number 3 we don't have a value for designation, right? So this is what a real world table would look like, right? Now for each column we have a particular type of data, right? We cannot store anything that we want in any order, right? So the first item has to be id, the second item has to be a name, right? The third id has to be a manager, right? And this column has to be a salary. So in database we have the concept of data type for a particular column. So in this data type I can only store string data type, I cannot store number, right? Similarly in this data, in this column I am supposed to store salary, that is a number, so I cannot store a string here, right? So when it comes to a database, each column is supposed to adhere to a particular type of data, right? I cannot randomly put any data type into any column. Okay, so that was the theory part, right? Now let us see how we can create our own tables inside our database, right? So for that we have the SQL command, right? So that's what we will learn. So the command is, it is create table, right? And I will give the table name. So I will say employees. Okay, then this bracket, and it should end with a semicolon, right? And within this I have to define my table, what my table would look like, what are its columns, and for each column what is the data type that I have to specify, right? So my first column is my id column, right? And I am saying it should be of type int, right? After that comma, right? Then second column I want it to be called as name, right? And what data type I want it to be, it is a string data type, right? So here in database we call it as varchar, right? Which means I think a variable character, and I have to give it a value. That means this name can hold 200 characters, right? Again comma, next column definition, right? I will say designation, right? What should be the data type of designation, right? Also here I want it to be varchar of 200, right? Comma, then what I can do, I'll add a value called salary, right? Salary, what I want it to be, I want it to be of type integer, right? Now for this example I have only used integer and varchar, but there are lots of data types and eventually we will look into all of them. But for now, just for sake of this example, I have taken 4 columns, each of them have two different data types, integer and varchar, right? Now this would work, okay? So it has to be ended with a semicolon, right? Now there is a good practice what we usually write. See, usually we don't write script manually in the editor, right? So it usually runs in some type of automation, right? Either through a migration script, right, or an automated script that runs. So what I can do is create table. This will work. But what if the table already exists in my database, right? So it is a best practice to add if not exists, right? Create the table only if it doesn't exist, right? So that if this script runs again and the table exists, it will not throw abrupt errors, right? Which obviously no one wants in production or anywhere, right? So this is the command, create table if not exist. It's a good practice, you should add. Then your table name, then your column name, data type, your column name and data type, right? Like this you can add. Now I will run this one and we'll see what happens. So I'll say control enter, right? So if you see this message, it has created the table now, right? Now the table is created, right? But how I will know, like what kind of table is created? Did it create according to my definition, or did it create something else, right? So I'll remove this one, right? And I will say DESC. That means describe. Describe what? Describe my new table, which is employees, right? And semicolon. It has to end with the semicolon, right? And to run this one, I will say control enter. Right now, I got my definition. One thing I can do is move this to here, right? Okay, this might look better now, right? So if you see, I added a field called ID, which is of type int. For now, you can ignore these values. We will take a deeper look into what is this, what is null, what is default, all these things. We will take a look into that later. For now, what I created ID, which is integer, name, which is varchar, designation, varchar, and salary int. Okay, that means this describe table command will describe the table for me. Now we'll check the next command related to table, that is drop table employees. Now what this will do, obviously it will drop the table. Be very careful when you are running this command. Only if you are absolutely sure that you want to delete the table, that's when you should use this command. This is irreplaceable command. You cannot get the table back, right? So be very careful. If you are using a production database, avoid this command. Okay, I'll not run this one. Just for your reference, I have dropped the table. Once table is created, what next? Of course, you have to insert the data, right? Otherwise, what's the point of having a table, right? Next, we will learn how to insert data into the table, right? So for that, what command we will use? Of course, it will be insert into employees, right? Insert into employees. We want to insert values, right? What are those values, right? So I have to give the values in the same order in which I have created the columns. So first I have to give ID, then it should be name, then it should be designation, and then it should be salary, right? So I'll say ID1, right? What should be the name? I'll give a name, right? John Doe. Some name you can give, right? What is the designation? Manager, right? What is the salary? 50,000, right? That is the salary I want. And semicolon, right? So I do it like this. Okay, now it is visible. So what I have done, insert into the table name, that is employees, values. What values? ID1, the name, the designation, and the salary, right? This is what I'll insert, right? So I'll say control enter, right? So it says affected rows 1. That means it has inserted one row. Okay, now sometimes it might happen that at the time of insertion we don't know all the values, right? For example, I don't know what is the uh, designation and salary of an employee, for example, right? In that case, what I will do, so I will say insert into employees, right? Now earlier what I did, I said values and I started inserting, right, based on the order in which the column exists, right? Now since I don't know all the columns, I have to explicitly tell that what columns value I want to insert. So here, right, what I am saying, I don't know the value of other fields, but I am going to insert ID and name, right? So I'll say ID2, name is Jane Smith, right? And semicolon, right? So if I don't follow the order, or if anything is missing, then I have to explicitly tell into this insert into command what values I am inserting, right? If I do this one and run this one, I'll say, it will say one row affected, right? That means it has inserted, right? I'll remove this one. I will check one more example, right? Now, okay, I want to insert data, but not in the order in which it appears in the table column list. Okay, so for that, what I can say, insert into employees, right? Now I'll say I'll insert the name first, designation next, ID next. Okay, and I will say values, and I have to give the values in this order. I have to give the name first, right? After name, I have to type the designation, right? And after designation, I have to give the ID, right? So the order has to be maintained. Name will go as Bob Johnson, designation will go as analyst, ID will go as 3, right? Now let us run this one, right? One row inserted or one row affected, right? So this worked. Now I want to insert multiple values. Now I was only inserting single values, right? So what I can do is I'll remove this one because I'll insert everything, right? And in the same order, right? So what I can do is right, so insert into employees, and here I have not given anything in the bracket. That means I'll insert everything and in the order it appears in the table, right? I'm saying values, and then I'm giving comma separated multiple values. Here I can give more values also. I'm just showing with two example, but I can enter as many values as I want. Okay, if I run this one, right, if I run this one, you see affected rows 2. That means it has successfully inserted 2 rows, right? That's how I can insert multiple values. Right now, is it possible for us to insert null values? Yes, we can insert null values, right? So I will say insert into employees, right? What values I want to insert? ID, name, designation, right? What values I want to insert? I'll say 6, right? Give it a name, right? And when it comes to designation, I will say null because I don't know what is the designation, so I'll keep it as null, right? Now if I run this one, right, it will insert it. Now what I will do is I will add few more insert statement, right, so that we can further work on our next topic, right, so that we can use this data, right? So I'll insert this, so I'll say control A and run, right? So it has inserted many items, right? The next section is about selecting our data. That means till now we have only inserted data into the table, right? Now I should be able to fetch the data from the table, right? So that I will know what data is there and do some analysis on the data, right? So how to fetch data? For that we use select statement, right? So what does the select statement look like, right? Select something, say ID comma name from your table name, right? That means what I am saying is from table employees give me all ID and name fields, right? Now if I do enter, you will see the data here, right? So I have these many ID and these many names, right? Now what if I want to select all the fields, right? I don't know how many columns are there, but I want to select all the columns out of that. So for that, what I will use, I'll use star. That means select all fields or all columns from my employees table, right? So if I run this one, I'll get the additional 2 columns. Okay. Now there is a possibility that my table has millions and millions of records, right? And I don't want to fetch millions of record. I just want to fetch, say, 10 records out of that. This command will give me all the records, right? Now what I have to do is I have to make sure I only get 10 results. For that, what I will use, I'll use limit and a number. That means select all columns from employees and limit it to 10 rows. Okay. Now if I run this one, I'll get only 10 rows, not more than that. If we have, say for example, only 9 rows, and if I give 10, what will happen? It will only give me 9 rows. This is the maximum limit. Okay. If I have less data than this one, that's fine. I'll get the lesser amount only. Now, suppose your boss comes to you and he asks, can you tell me how many employees are there in my employees table? Right? So, what I can do, I'll remove the limit, of course, because if I say limit, it will only give me 10, right? I want to count how many employees are there, right? So, I will say count all rows. It will say count all rows from employees, right? So, you can tell your boss, okay, there are 39 employees. Why? Because I got 39 in the count column. Right now, what I can do is I can create alias. What is the alias? If you see here, the heading of the table says count star. I don't want count star. What I want is employee count, or total number of employees. So for that, what I will do is I will bring this from employees down, and I will say as select count star as, I will say total emp count. That means whatever is the total count, assign it should be total, total employee count, assign it to that name, right? So if I run this one, it will say total employee count is 39, right? Next concept, filtering, right? So this is select statement I am doing, right? But I don't want always all the data, right? I want to filter certain category of data. For example, your boss will come to you and he will say, can you give me list of employees who are manager, right? So what you will do, so I will remove this, I will keep star, right? And I will run this one, so we'll get our regular data, right? Select star from employees, right? Now what we have to do, we have to find all the managers, right? So what I will do is I will say where is the filter condition. That means select everything from employees where something. What is that something? Where designation equals to manager, right? So if you see the table, we have one manager here, one manager here, one manager here, right? So what this should do, it should filter out all rows in which we have designation as manager, right? So if I run this one, right, you see we got these many rows, and if you see designation, each of them are actually manager, right? Now your manager or your boss will come and ask you, okay, can you give me count of this one? So previously we have learned that I can put a count, right? Now what will happen? Oh, there are 10 managers in this employee table. So I will change this one to normal, regular select star, right? And here also, if you want, you can only select, say for example, name. Give me only names where designation is manager. I don't want ID, I don't want designation, I don't want salary, I just want name, right? So here, if you select name, that means you will only get name, right? So these many named people are actually have designation of manager, right? So I'll say back to star. Next, what I want is I want to find all people who have salary more than say 50,000, right? So how can I write that? So of course it will be select start from employees where, right, where I'll use the salary column, right? And what is the condition? Salary should be greater than 50,000, right? And I will run this one. So if you see the salary column, all of these are greater than 50,000, right? Now here, if I can do greater than, I can do less than also, right? So we'll get all employees whose salary are less than 50,000. If I can do greater than or less than, I can say greater than equal to as well as less than equal to, right? And right, so I can run this one also now. So I'll get, is there a value exact 50,000? Here, right? So this includes 50,000 as well, right? And if I can do this, can I say not equals to 50,000? If it says greater than, less than equal to, greater than equal to, then I should be able to do not equals to, right? Not equals to 50,000. If I run this one, I'll get all columns which is not 50,000. It can be less, it can be more, but definitely not 50,000, right? So these are all the mathematical operations that we can do, like comparison operations that we can do on the where condition. I will again make it greater than 50,000, right? Now next concept, what I want is I want all the employees whose salary is in between a certain range, right? I want, say for example, within 50,000 to 60,000. In between that, find me all the employees. So for that, what I will use? I'll use the keyword between 50,000 and okay, say 70,000, right? Right. So what I'm saying, select start from employees. That means select all columns from employees where salary is in between 50,000 and 70,000. Right. Now if I run this one, I'll get my result. So if you see the result here, I have a particular salary called 70,000 and there is salary column called 50,000. That means this between is inclusive of this value and this value. Okay, so if it has a value of 50,000 exactly, it will pick that also. And on the higher end, if it has a value of say 70,000, which exact matches, it will pick that value also. Okay, now next question, or we'll proceed further with few more examples. So we can use and or operator on the where condition, right? That means, okay, let us take an example. Find me all the developers who earn more than say 50,000, right? All the developers, which means the designation is a developer designation, salary is more than 50,000, right? So what I can say, where, right, where designation equals to developer, right? And I have to use and, okay, and salary is greater than 50,000, right? And semicolon. So what this will do, all the developers who have salary of greater than 50,000 will be filtered out, right? Let us see, right? So if you see the table, the description, the designation is developer, all of them are developer, and salary is more than 50,000, right? Very simple example, clear example, right? Instead of and, I can say or, right? These two are logical operator, right? So what I can say, just another example, designation is manager, or they are earning more than 50,000. That means either this is true or this is true. If any one of them is true, that means that row will be picked up in the filtration. In case of AND condition, both of the condition has to match, then only it will filter. Right now, either it should be a manager designation or salary should be greater than 50,000. Right? So if I run this one, let us see. Right? So if you see here, salary is less than 50,000, but if you see designation is manager. Right? That's why this row is picked up. Right here, if you see, designation is not developer, but definitely salary is more than 50,000. That's why this row is also picked up. So that's how AND condition will work. Right now, next example. Right, I'll comment on this one. Right now, what we want is designation is not an analyst. So I want all those people who are not analyst. Except analyst, give me everything. So how can I write that one? Where designation, where I'll say not what designation. What designation is not? I'll say analyst, ANALYST. Okay, that means give me all rows in which the designation is not analyst, right? And I will say semicolon and run this one. Right, so if you see here, we have everything: manager, designer, developer, but you will not find analyst. Right now, what I want is I want to get all designation which is either a developer or is an intern. Right, so what I can do, where designation, I'll use the condition in what it will take comma separated values. So what I can say, in developer or intern. Right, and it should end with semicolon. That means filter out all employees in which designation is developer or intern, and developer DEVLOPER, correct spelling. Okay, so it should either be a developer or it should be a intern, right? And I'll put it to next line for better visibility, right? And I will run this one. Right, so I get all developers and there are 1 and 2 interns. Right, so designation is either a developer or an intern. Right now, if you remember, I said all of the values might not be available when we have the data. Right, some fields might be null. Right now, if you see here, we have a null field called salary. We don't know what is the value of this one. That means it is null. Now I want to figure out all the employees whose salary is null. Right, we don't know what is their salary, so I want to figure them out. Right, so what I can say, where salary is null. Right, that means give me all employees where salary is null or whose salaries are null. Right, so if you see, I get salary and everything is null. Right, so this is how you can work with null. Right, and if there is a null, obviously there is not null. Right, so this will just work the opposite. Give me all employees in which we know the salary value. It should not be null. Right, so I get all the employees in which I have salary value. It is not null. Okay, so now next concept is pagination. Right, you must have heard about pagination, right? So if you see this Amazon page, right, this is paginated. That means I might have hundreds of records with me, but on the front end I'm giving only first 10. Then if you go to next page, I'll give you the next 10. If you go to the next page, I'll give you further next 10. Right, so obviously this concept is known as pagination. Right, similarly in database we might have thousands of record, we might have lakhs of record, right? But we don't want to send all the records, we want to paginate it. Right, I want to send it page by page. Right, so how can I achieve this one? Right, so if you remember, I explained about the limit query. right? So select star from employees, right? Limit 10, right? If I run this one, I'll get the 10. I'll get 10 results. Now with this query, I'll always get the 10, those 10 results, right? But I want to have a paginated result, right? So what I can do is, there is a property called offset. That means it will give limit of 10, but from where it will start, right? So I will say offset of 0. What is the meaning of offset of 0? That means it will start from the beginning. Start from the beginning and limit 10, give me records, right? So if I run this one, I'll get the records. This is page 1. If I have to go to page 2, what I can do? I'll say offset 10. That means skip first 10. After that, pick few items and limit that to 10, right? So what I will get? I'll get the next record, next set of records, right? Next paginated records, right? Or page 2, you can say, right? How can I achieve page 3? Offset it to 20. That means skip first 20. From 21, give me 10, right? Right. So now we'll go to our next concept. That is a case statement, right? So what is a case statement, right? In programming languages, we have switch cases, right? Something similar. So I will show you. Now, what is my requirement? My requirement is, in the employee table, what I have to do is, I have to show another column called called as salary classification, right? And based on a particular range of salary, I will say high salary, mid salary, or low salary, right? This is what I have to display, right? So what I can do, select star from employees, right? Okay, now instead of select star, what I can do, I can add all the values that I want. I want ID, I want name, okay? Just these many things, okay? Then what I want is their salary classification. Say for example, for a particular salary range, I will say high salary. That means how I can achieve that one, I will say case, right? And I will say and as salary classification, right? Now that means within a case statement, I can add certain conditions. Based on that, I will add a then statement. So let us check the example. Case when salary is greater than equal to say 75,000, then high. Okay, I will say when salary is greater than equal to 50,000 and salary is less than 75,000, then what I want to say? I want to say mid, right? Else whatever is there, I will say. Then I can say another when salary is less than 5,000, I will say then low. Else what I can say, unknown salary, because there are few null columns in the salary also, right? Which I don't know. So I can say that means for each row, see what is the salary. If it is greater than 75,000, mark it as high salary. If it is between 50,000 and 75,000, mark it as mid salary. And if it is less than 5,000, mark it as low salary. Okay, and this should be 50,000, so that it will be within the range, right? Less than 50,000. Yeah, so this is greater than 50,000 and less than 75,000. This is anything less than 50,000 will be low. And if there is anything else, it will be unknown salary. And this value high and mid and low will be inside a column called as salary classification, right? This is the alias, right? I will end this with semicolon and I will run this one, right? So if you see, I get the ID, I get the name, and I get low, unknown salary, low, mid, right? Like that, I get all the values, right? So this is the example of a case statement, right? Right, now one more small concept we will check. So I will say select star from employees, right? And I will run this one. So if you see here, there is a salary called null, right? And there is a designation called null, right? So when we try to generate a report out of this, right, we don't want to have this null column, right? This doesn't look good, and non-technical people will not understand what is the meaning of null, right? So for that, what we can do is, instead of null, we can assign it a default value. That means I will say, okay, ID as usual, I will select, right? So select ID, right? Name. Till here everything is fine, but I know few designation have, null. So what I can say, if null of what? If null of designation, then add unknown, right? That means if null, that means if designation is null, mark it as unknown. Similarly, if null of what? Salary, I will mark it as 0, right? Now I will run this query. Now if you see, I have few 0 columns, I have few unknown. Maybe if you want, you can change the string, instead of unknown you can assign some other string, but you get the idea, right? If it is null, replace with this value. Now the report looks clean, and people who are not from tech background, who don't know what is null, they will understand, okay, we don't know what is the designation, and the salary of these people, right? That is 0. And if you see, it says if null in the header, right? So I can say as designation, and I'll say as salary, right? So I'll run this one. Right now it says designation and salary. Okay, now we will go to the next phase. That is, till now we have seen how to create data and how to read the data, right? Create data from create table statement and read data from the select statement, and we have learned different types of filtering on that, right? Next, the logical things come is updating the data, right? I have a table, I know there are some data, I want to update it, right? So how can I achieve data updation, right? So I'll remove this one. We'll start. So I'll take one example. Okay. So here there is a person called John Doe who is a manager whose ID is 1. Right now, your boss comes and tells you there is a person whose name is John Doe whose ID is 1. He is a manager. You have to mark him as senior manager, right? So what I will do, first let me check whether he is right or not, right? So I'll say select star from employees, right? So we have learned about where condition. So what did my boss say? Where ID equals to 1 and designation equals to manager, right? I'll run this one, right? So we have two entries. I think there are duplicate entries, but the concept is clear, right? So I have an employee ID 1. He is a manager. I want to mark him as senior manager, right? So how can I update this one, right? So what I can say is update employees, right? Now what we have to update? For that we will say set what? Designation equals to senior manager, right? Now very important part, when you are doing update you always have to add where condition. If you don't add where condition, it will update everything in the database, which we don't want, right? Be very careful when you are running a update statement in production database or in any database. You always have to add a where condition, unless you want to update the whole table, right? Otherwise big screw up, right? So, right, what will be the where condition? The where condition will be same as this one, right? Because this is the person I want to update. So update employee, update what? Designation, set it to senior manager, where id is 1 and designation is manager. Now when I ran this previously, it was manager. Now I will run this one, right? Affected rows 2, because they are a duplicate data that you can ignore, but anyways the update has happened, right? Now we will check. Now if I run with this condition, you think I will get any result? I won't get any result, right? Because there is no person with id 1 and manager. Now it has become senior manager, right? So I will search as senior manager now, right? And I'll run this one, right? Now John Doe is a senior manager, right? So this is the concept of update in a nutshell, right? We will check a few more example, right? Now your boss comes to you and he tells you, okay, increase the salary of all developers, make it double, you know, all the developers double their salary, right? So what we can do? Update employees, of course. Set what? Set salary, right? Set to what? Salary times 2, right? Where I don't want to run any id, I'll say where designation equals to developer, right? So I will say I'll copy this condition and I will paste it here just to see what we have current data now, right? And I'll remove this where id. Okay, so we have developers, this is 20,000, this is 70,000, like that. Now I will run this query, this update statement, right? It says 10 rows affected, right? Now let us take this 20,000 and 70,000. This should have become 40,000 and 1,40,000, right? Let us see, right? So 40,000, 1,40,000. So all developers have got their salary doubled, right? So this update statement, all you have to do is be very careful with your where condition, right? Based on this where condition that we have learned, right? Between not null, right, is null, all those things will be applicable here, and based on that you can run the update statement, right? Now what I can say is, let us take another example. So all the people who have salary of null, assign them a salary of 10,000, let us say, right? So first let me see what is the data in which salary is null, right? So where salary, right, is null, right? Let me check. So we have some data in which salary is null, right? Now your boss says, okay, give them 10,000 minimum salary. So I'll say update employee, set salary equals to 10,000, where salary is null. Of course that will be the condition, right? Where salary is null. I will run this one. 15 rows affected. Now if I try to run this query, will I get any result? No, right? Because there is no longer any column in which salary is null. I have updated everything, right? So this query, earlier it used to give me few result. Now it is empty, right? Done. So this is update statement in a nutshell. Be very careful with your where condition. Double check with a select statement. whether you are getting the same result that you want to update. Based on that, you do the update. Okay. Now the logical next step is delete, right? Delete is very similar to update. You have to give the where condition, and I said be very careful with the where condition in update. You have to be double careful when you are writing a delete statement with the where condition. If you don't add a where condition, everything will be deleted. Be very careful. Here we are working with temporary data, rough data. That's fine. We will run thousands of delete statements. That's fine. When you are dealing anything in production about delete, be very careful. And so I'll keep the where condition. Okay, right? So we'll learn about delete, right? So delete, what will be the syntax? Delete from, right, table name. Delete from table name. If you only run this one, your table will be deleted, right? But we don't want that. We want a where condition, where id equals to 2, say. So I want to delete the person with id 2. Right now, if I select id equals to 2, right? Of course, duplicate data, that's fine. We get 2 columns, right? Now I want to delete this one, right? I delete. So it says 2 rows affected, right? I run this one, the select statement. Of course, I won't get anything, right? Because id2 is deleted, right? And here all the where condition concept remains same. The your null, not null, in between, greater than equal to, and or, all the where condition remains the same. All this will do is delete from that particular table all those rows which matches your where condition, right? We'll take one more example. Delete from employees where designation is intern, right? I want to delete all employees where designation equals to intern, right? Will delete 2 rows affected, right? Now if I take this where condition and run a select on this one, of course we won't get any data, right? Because it's all deleted, right? We won't get any data in which designation is intern, right? So that's the concept of delete, and use it with utmost caution. So the next concept that we will start learning is string methods, right? So we have a varchar data type in our database, right? So for that type of database, there are some string methods that are given. For example, concatenation, converting it to uppercase, that kind of sometimes is our task. So let us start looking into those kind of methods now. So I have removed the employees table and all other tables that we have worked before. Now we'll start again from fresh. So what I will do is I'll create another employees table. Okay. So I'll run this command. Okay. Once that is done, I will insert few dummy data into this, right? So I'll execute this one and I will execute this one, right? These are just dummy data, right? If you have this schema, you can generate this data from your own, right? Now, with that being done, what I will do is we'll start with our first method, that is concat method, right? So what I want is I have a column called first name and last name. So what I want to do is I want to display it as a single string with a space in between. Okay. So for that, what I can do, I'll use the concat method, right? So I'll say select, right, something from employees, right? Now what I will add, I will say concat, right? What I have to concat? First name, right? And with that, I will add a space, right? And I will say last name, right? Then I will give it a alias as full name, right? Now that being done, what this will do? This will select the concatenated result of first name space last name as full name from employees table. Right, now what I will do, I will run this, right, and I will just adjust the view, right. So if you see, we get the information as full name, right. So this is very simple example of concat, right. Along with concat, we have another method called concat ws means with separator. So here, instead of space, what I can do is I can give my own separator, right. So how the syntax will work, I will remove this one. Okay. So first I have to give the separator. Here I can give any separator. It can be comma, it can be hash sign, any separator I can give. Right. So for now I'll just give comma. Right. And the next parameter or the next parameters that I will pass are the, say for example, last name and first name. Right. Now what I should see, the last name and first name separated by a comma, right. So that is what concat ws will do, right. Let me run this one, right. So if you see, separated by comma, right. If I want, I can give any other string character also, right. So let us try with star, right. I will run this one. So you can see star is added in between this string. Okay, and I can pass any number of parameters, right. So what I can do is I can pass, say for example, another string Mr. Right, just an example. There could be gender specific title, but just for example purpose I have added Mr. Okay, so what I will do, one comma is missing, right. What I will do, right, see Mr, then star, then do, then John. So you can concatenate any number of list of items, list of strings, and this will be separated by this symbol. It could be anything, right. Next we will check the length method, right. So as the name suggests, it will give us the length of the string, right. So what I can do, let me select first name, right, and length, right, length of first name as f name length from employees. So what this will do, this will display first name as well as length of first name, how many characters are there in that column, right, and it will give alias as f name length, and it will pick from employees table, right. So if I run this one, let us see. So if you see here, 4 characters, right, 3 characters, right, 7 characters, so that like this I can get the length of the characters or the length of the varchar type, right. Now what I want to do is convert it to uppercase, right. So what this will do, I change it to f name upper, right. So what this will do, this will convert it to uppercase characters, right. So if we run this one, it will convert it to uppercase characters, right. And similarly in the same line, obviously we will have lower, right. So this will convert it to lower character, right, f name lower, and of course this will work with all columns that are of string type, right. So just for the demo purpose, what I will do, I'll say last name, right, and I'll say L name. I'll remove the additional backticks, right, and I will run this one. And here maybe I can give last name better, right. Right, run this one, right. So if you see, this is converting it into small case, right, or lower case, right. So next is the trim method, right. So if you know what to trim will do, what trim will do is, so the trim method, what this will do is trim the additional space from left and right side of the characters, right? So if I run this one, as such, I think we don't have any data with additional space, right? But you get the idea, right? What this will do is it will remove if there are additional space. So if I have to demo this one, what I can do is I can use two different methods, right? I'll say concat, right? Concat, right? And what I will do, I will add a space, right? And add couple of space, right? And for now, let me remove the trim method, right? We'll see some space, right? So if you see here, we have some space, right? If you see the additional, this blue highlight, right? From here to here and from here to here, there are additional space, right? You can see here that highlight is coming extra, right? After H, there are two more places in which I have the blue highlight. That means those are the space characters, right? Now, what I will do, I will trim it, right? Now, if I run this one, you can see I don't have any additional highlight, right? It start from S and it will end at H, right? There is no additional space or additional blue characters, blue highlight that is coming, right? So that's what trim method will do, right? Now, substring method. So what this will do, it will, from a particular string, it will take some part of that string, which is called as a substring, right? So what I can say, address, right? Let us work with address. What this will do, I will say substring, right? And I will remove all of this, right? This concatenation, I'll say substring, and this is not address. I'll work with email, right? Substring, I will say email, start from first character and give me 4 characters, right? So from email, generate a substring starting from 1 ending at 4 character, right? So if I run this one, if you see, first 1 2 3 4 characters are displayed here, right? Similarly, Bob dot, right? That means 4 character displayed here. Here if you see ALIC, Alice, 4 characters displayed here, right? Now on top of this, can I use other string methods like previously I showed inside the trim I had concat method, right? So here what I can do, I can say upper, right? So this will convert it into upper, right? And here I should change the name, right? Email chars, right? So few email characters, that's what it means, right? So now if you see, this is in small case, right? I will run this one, right? So if you see, it converted into uppercase. That's how you can use multiple string methods also, right? Then next string method is replace, right? So here I will change it to address, and here I'll remove this one as well as this one, right? Here replace. So what this will do is it will pick a particular substring, it will replace that substring with another string, right? So what I want to replace, I want to replace address, or in the address I want to replace something, right? Now what I want to replace, if there is a title called F, I want to convert it into avenue, right? So wherever I find AVE, if or F, however you pronounce it, I'll convert it into avenue, right? As address new, or you can give any alias, that's fine, right? Now what I will do is I will run this one. Okay, so if you see the second example, we have Oak Ave, it converted into Oak Avenue, right? So this is what replace will do, right? So the next method is locate method, right? Let us see what locate method will do. So what I will do is I will first take position, right? The position column, right? And I have to see if in the current column my position is of a given type, that means what I will do, I will locate, okay, what I will want to locate, I want to locate HR. Where I want to locate this one? In position. That means for this current row is my position HR. Based on that, what this will do, it will give me a character 0 or 1, right? So let us run this one, right? So position developer, which is not an HR, that means 0. Manager 0, right? We have HR specialist. Here I get 1, right? Do we have ones anywhere else? No. So this is one example, right? Here we have HR. So what it did, it tried to locate HR in position, and for one HR position called as HR specialist, it gave me 1. That's what locate will do, right? So we will go to next concept, that is a distinct statement, right? So what a distinct statement will do, let us see. So what I can do is, I'll say select star from employees, right? Let us run this one. If you see here, right, we have different departments, we have different address, we have different positions, right? What I want to do is, I want to find, say for example, all the distinct departments that I have, right? List of all departments, right? So what I will do, what I can do, I'll say select distinct department from employees, right? So now what this will do, this will give me distinct list of all departments. That means I have IT department, I have HR department, I have finance, I have sales, and I have marketing. All the rows in the database belongs to any one of this department. That's what it means. There is no more department. These are the total list of all possible departments in my table, right? Can I say same thing for position? What are different positions available in my employees table? So I can run this one, right? We have developer position, we have manager position. These are distinct positions, right? Sales representative, database administrator, right? That's what a distinct will do, right? Now what I can do is, can I add a count on this one? What this will do, this will just count how many positions I have. If you see, the serial number is 14 till here, right? So what this count will return me, 14, right? So there are 14 distinct positions available in this employees table, right? So distinct was very simple, small concept. We'll do one more small concept, that is order by, right? Now if you do select star from employees, right? If you see, it is ordered by the primary key, right? Based on 1 2 3 4, like that. What I want to do is, I want to order them by last name, right? So if a last name starts with A, it should appear on the top of the list, right? So for that, what I will do, select star from employees, then I will do order by, what? Order by last name, right? And what I want to do, I want to do it in ascending order, ASC. So select star from employees. Till now we know this much. Order by means put it in an order of last name ascending, right? Now if I run this one, you see here A came first, then B, then C, D, E, like that till W is the end. Here if you see, this key is not in serial order anymore. The primary key is no longer in serial order, right? It has ordered the table by the last name ascending. If I have ascending, I have descending also, right? So now this W should come first and A should come last. That's what descending will do, right? So we will run this one, right? If you see, this W came first, right? This is in descending order, and similarly we have A at the end, right? Similarly, you can perform the order by with integer columns also. So it will sort it based on the integer, ascending or descending. So for example, if there was a salary column, I could have sorted based on salary. So it will filter out, or it will order the table from salary higher to lower or lower to higher, right? So based on that, order by condition works, right? It will just order your table, rearrange the rows so that for a particular column type, it will sort it in a particular fashion, either ascending or descending, right? Okay, so the next concept is like condition, right? So we have seen where condition, and it will be filter based on and condition or condition, right? Like that, or greater than condition, equal to condition. Now for string, we have a like statement. What this like statement will do is, I'll remove this one, right? What I want to do is, I want to filter all employees where the last name ends with an S, right? So for that, what I can do, select star from employees where last name, I'll say like, okay, what does it look like? So I'll use wildcard, right? What I want to have is, it should end with S, right? So whatever it starts with, it should end with S, and whatever it should start with is represented by this percentage sign, right? So pick me anything, and at the end it should have S, right? So if you see, we have this Williams, another Williams, one Roberts, one Jones, right? So it will pick up all this. This is a wild card. That means anything, and at the end it should have S, right? So I will put a semicolon and I will run this one, right? So what happened? S, all that ends with S, right? It gave me, right? Similarly, can I say like this? It should start with an S, right? And after that, it can have anything, right? So if I run this query now, what this will do? It should start with S. After that, wildcard. That means anything can go here after S, as long as this condition is met. That means it will be picked up. This is a wildcard, right? Now, can I put wildcard on both sides? Yes. That means it should start with anything. Somewhere it should have an S, and then again wildcard. That means it can have any value, right? Now if I run this one, right, all those things that have S somewhere here, if you see S, right, if I can make it as S and O, right, it should start with anything. It should have S and O in between, and then it should end with anything, right? Now if I do this one, right, if you see SO, SO, right, and SO, right? So this is what a like condition, right? This is the wildcard. You can place it however you want, and it will do filtering based on your wildcard conditions, right? The next concept is group by, right? So what group by will do? This will do grouping based on a certain condition, right? So let us take an query example, right? What I want to know is, we have department IT, we have department HR, we have department sales, right? What I want to do is count number of employees for each department, right? That is my task. So what I can do, of course, I'll do select star from employees minimum, right? From here, if you see, I have department, right? Now if you do count, right, what this will do, this will count total number of employees in the table, right? But what I want is count for each department, right? So what I can do is, I'll say group by department, and here what I can do, I'll write department. That means give me department as well as count of each department from employees, group them by department. That means now if I run this one, you can see here IT has 6 people, HR have 4 people, finance have 5 people, and like so on. So what I have achieved here, this is a group by statement. Group by statement, what this will do, this will group all the rows based on this department, right? And we have to add this department in the select list, and this will work only with aggregate functions, right? Now this count is an aggregate function. Now since I have started talking about aggregate function, the next topic that we will look is aggregate functions and see what more things we can do with group by and aggregate function, right? Right, so we will start with aggregate functions, right? So what I have done, I have dropped the employees table so that we can again start from scratch, right? I have this table definition, right? I will execute this one, and I have some dummy data that I will run, right? So it has inserted all the data, right? Now on this we will start learning aggregate functions, right? So first aggregate function is count, right? So we have already seen that one. So what I can say, select count of star from employees, right? So we will get total number of count, right? Very simple, right? Now there is another method called as sum. Of course, sum will not take star. What this will do, it will take a column in which we have some integer value or decimal values, right? So what I can say, sum of salary, right? Now if I run this one, I'll get total sum of the salary of all the employees. So this is sum. Now can I use sum and group by? Because in group by I said we have to use it with aggregate function, right? Now what I can do, group by department, and here I'll say department. Here we have to mention whatever column we are doing group by, that we have to add it in the select list, otherwise it will give error, right? So department and sum of salary, group by department. So what this will do, this will group by department, and for each department it will count the sum of the salary, right? So if I run this one, what it did, IT, what is the sum? This much is the sum of all employees from IT department. This much is sum of all salary from sales department, right? And like this, right? Now we have a function called avg, which means average, right? Now if I run this one, what this will do, it will find out the average. That means total number of people, means their salary addition divided by the total count. That's what average is, right? So this will do average of salary for each department grouped. That means for each individual department, this will count the average salary, right? If I remove this one, what will happen? And of course I have to remove this one. So this will give me average of all employees across the table, irrespective of department, right? So I'll bring back the department, right? Now it will give me data department wise, right? Now in the same line we have min. That means minimum salary of each department, right? That is some value for IT department. 60,000 is the minimum salary someone is getting. And if we have min, we would have max, of course, right? So I'll run this one. This will give me max. So now the next is group concat. So what this will do, now I have department, right? And I have the max salary. Now what I want is, I want a list of all employees in each department, right? So what I will do, right? I'll say group concat. Group concat what? Group concat employee name, right? So what this will do, filter it by department, and for each department it will give me comma separate value of each employees, right? So if you see here, right, there is a comma separated value for each employee who belong to finance department. For HR department, for IT department, this is list of all people, right? Now here, can I do this order by? We have learned order by before, right? But I can say order by department. So what this will do, it will try to arrange this department based on the alphanumeric sorting method, right? So if I run this one, let us see. So F HIMS, it's sorted, right? So if I don't specify anything, it will be ascending. If I have to mark it as descending, I have to completely specify it as descending, so it will do the reverse sorting. Right now, sales scheme, marketing, IT, HR, finance. So I just showed you how we can use multiple conditions like this, right? Right. So the next concept is having clause. Now, what is a having clause? So we already have studied where condition, right? Where condition, based on some column, we'll filter it with a where condition, where it is something equals to, or it is greater than, or it is less than, and like that. When it comes to aggregate functions, we cannot use where condition. We have to use having condition, right? So let us see with an example how we will use having. So what I will do, department, and I will back to count, right? Count a star, and I can remove this one order by. So what this will do, this we have already seen. It will give me count for each department, right? Now the condition is filter out all department in which we have minimum 4 employees, right? 4 or more. So here what I will use, having, instead of where I will use having. Having what I can do is this count, I'll give it as an alias as emp count, right? Then what I will do, having emp count greater than equal to 4. So what this will do, now I have department and their count, right? Now I want to filter out all department in which count is less than 4, right? So now if I run this one, what happened? 5, 4, 4 and 4, right? So based on this count, or based on this aggregate function, we have to use having condition, right? Where will not work here. So where, if I say where employee count is greater than equal to 4, right? This will throw syntax error, right? Where we cannot use on output of aggregate functions. This is a very important interview question. Okay, having, right? Now we'll take one more example. We'll say average of salary, right? What I will do for now, let me remove the having condition, right? We have average salary, right? What I can do is average salary is more than 1 lakh, right? So what I can do is having, okay, and what I will do is, if I'll change the alias name, avg salary, having avg salary greater than what I can say, let me say 85,000, right? I'll say 85,000, right? So this two should be filtered out, and I should have only HR, marketing and finance, right? So I'll run this one, HR, marketing and finance. That means having, first what I did, select department, average salary from employees, group by department, having average salary of more than 85,000, right? That's how I can calculate average salary for each department with a filtering condition, right? So that's all about having condition. Just like where condition, you can use having with all those condition, like greater than equal to, less than equal to, not equals to, right? So that's the basic of having condition. If you want to filter out based on aggregate function, you have to use having condition, right? So next we will check what are the different data types in MySQL, right? So previously I told that currently we are only going to use int and varchar, and there are many data types. So now we will start looking into some of the data types that MySQL gives us, right? So we'll take column by column example. We will explore different data types that we have and how we can insert data into them, right? Let us start. So previously I created that employees table, right? I will delete and I'll recreate it with new columns, right? So if you also want, you can do this one. right? Drop table employees, right? So that we can again start from a clean slate, right? Now we will check one by one data types. So you already know integer and varchar, right? Date, timestamp, decimal, boolean. Four more data types that we are going to learn. So we will create our favorite employees table, right? So create table. You can use if not exist that I explained before. For now I'm skipping it, but ideally you should add. Okay, I'll say for now create table employees, right? Then bracket and it with semicolon, and inside that we will add our definition, right? So we will say I want to give it a column employee ID. It should be integer, right? We have already seen integer, right? Now what I want is first name, right? This I want varchar of 200, right? Then also I want last name, right? This also it will be varchar of 200. Okay, now I want to capture birth date, right? Birth date, what should be the value of this one? It will be timestamp, right? Also I want to capture salary, which is of type decimal. Decimal takes two values. One is the total length of the total digits of this of the number, and after that how many decimal values you want, right? We will look little more detail into the decimal, but for now it takes two values. First is the total number of digits, second is the decimal precision. Okay, right? And I'll add one more field is manager, right? This I want it to be of boolean, that means true and false, right? So we have integer, we have varchar, we have timestamp, we have decimal, and now we also have boolean, right? Now I will run this one, right? So it created the table, right? Now I will delete this one. I'll say describe employees, right? So if you see here, I get employee ID as int, right? First name, last name, birth date as timestamp, salary in decimal, and is manager is boolean, right? So if you see here, boolean is represented as tiny int. That means either we can store 0 or we can store 1. That's how boolean will be represented in the database, right? Now let's try inserting some data. Okay, so I will say as usual insert into, right, employees. I'll say values, right? So I'll insert all the values one by one in serial order. Okay, so I'll say one employee name, first name, right, John. Second name Doe, or the last name is Doe. Then I will add birth date, right? So for example, birth date is 1994. Okay, 2 then 20, right? So this is the day. So this part is day, month, year, right? And I'll add the this is the date. This will be the time. So I'll say 9:30:00. That means hour, minutes, and seconds, right? So I will add this one, right? So birth date is done. Salary, what I can say? I can say 60,000.50, because this is decimal, right? And decimal 10 2, that means the second part 2, that means I can add 2 digits in the decimal place, right? So this is the salary. Then is manager or is not a manager. So what I can say, true, right? I'll try to insert this one, right? And let me make some space here, right? So you can see the whole script. Insert into employees, values, and the corresponding value. ID, first name, last name, birth, salary is manager or is not a manager, right? So I will bring it back, okay, and I'll say run this one, control enter, right? So we have inserted one row, right? Now if we run a select star from employees, right, we will get the data, right? Right, the employee ID, first name, last name, birth date, salary, and is manager, we will get the data, right? Okay, now we will take a deeper look into the decimal, right? So what is this decimal? Decimal data type, it takes two arguments, right? First and second one. Now what are these two arguments? The first argument is the total number of digits, both, that is including both to the left of the decimal and to the right of the decimal. And the second parameter 2 is the digit which is on the right side of the decimal, right? That means before the decimal I can place 8 digits, after the decimal I can place 2 digits, right? That's what 10 comma 2 means, right? Now what I will do is I'll create another table, right? Create table salary, right? And inside the salary I will say employee ID as int, right? And monthly salary which is decimal, and let us say I'll call it as 8 comma 2. That means total number of digits can be 8, and in that the total number of digits after the decimal point will be 2, right? And I will say create table, right? Table is created. Now let us try to insert a few values and we will see examples on this one, right? So I will say insert into salary, right? Values. First value we will add is 1 comma 5000.50, right? Can I add more values? Yes, I can add more values, right? I'll say ID 2, right? And I will say 6000 and decimal places were 2, so I will say 987. I'll try to add 3 values now. We'll see what happens. And ID 3, say 8000, or I'll give 8 places and 90, right? Okay, now I'll try to insert this. We'll see what happens. And there is a space, no space is allowed between the number and the decimal, so it gave the error, right? So I'll run this again, right? So we get few out of range, out of range value. So it says out of range monthly salary at row. That means I tried to add more than what I specified. So I said 8. So total number of digits should have been 8. So I added 1, 2, 3, 4, 5, 6, 7, 8, 9. I think 9, 10, 11. I tried to add. That's why it is complaining, right? That's fine. Now we understood. Now what I will do is I'll run a select statement. Select star from salary, and we will run this one, right? So it did not insert anything, right, because of this error, right? So I will fix this error, right? And now I will try to insert, right? It now inserted 3 rows, right? Now if I try to read this one, right? So this is inserted properly, this value is inserted properly, Now if you see this value here, I should add only 2 digits after the decimal, but I have added 3 digits. So what it did, it rounded it up to the next precision. That is 87, it made it to 9, or that is 90. So 0 will be omitted, so it will be 99, right? So that's how it will behave. If you add more digit after the decimal, it will round up. If you try to add more digits before the decimal, then you will get the insertion error, right? That is decimal data type, more or less in a nutshell, right? Now based on your need, you can decide how much precision you want. If you want more precision into the decimal, based on what kind of calculation, what kind of data you want to insert, based on that you can change the value. It need not always be 2, it can be 3, it can be 4, it can be any number, right? Based on your need, you can create the decimal data type, right? Now can I do mathematical operation on decimal? Of course I can do, right? Because this is a decimal, right? I can do mathematical operation. So what I can do, I will say select, of course we have employee ID and monthly salary. Right now what I want is, I want to have one more field, right? So here I have select employee ID, monthly salary, and I want to have one more field called as annual salary. That means monthly salary multiplied by 12, right? So how can I do that? Simply monthly salary star 12, and I'll give it an alias as YEAR and Y yearly salary, right? I will make some additional space so that you guys can see. Okay, and one comma is missing here. Add the comma. Right now, I think everything is correct. Let us try to run once, right? We'll see. Yeah, syntax error here. It should be backtick, right? And run this one. Yes, I get the information, right? So this 5,000 has become, around 60,000, and as like it has multiplied it with 12, right? So you get the result. So we can do mathematical operation on decimal as well. So now we will see certain types of database constants. Now what is the meaning of a constant? That means we are trying to restrict the behavior of the column based on a certain need. See, I don't want my table to have any kind of value, like any kind of data, even if it's null. Some place I might not want to have null values, some place I might want to have unique values, right? It's not like haphazardly I will add any data that I want, right? So we use these constants to restrict certain type of data only, and it will filter out other types of data, right? Or at least it will give you the error that okay, this kind of data you cannot insert in this row, right? So we will check few such constants. The first constant is a primary key constant. That means you must have seen the employee ID or the ID column, right? So there is a possibility that a particular table might have same name for multiple people, right? There can be multiple people with same name, right? There can be multiple Alex, or there can be multiple Pauls, right? So if you want to uniquely identify them, you have to give them a primary key. Now what is a primary key? It's a ID that is unique across each row. It will, and it can never repeat, right? If you try to insert a repeated values, it will throw you error, right? So let us see how we create a primary key, right? So I'll drop the table, and because we will create fresh new table, right? Right. So by now you must have already learned the syntax of create statement, right? I have added it many times. Here also I have create table, and if you want you can add if not exists, right? For better practice. Now create table employees, right? This we already know, employee ID integer, first name and last name are varchar, right? Here if you see, there is a key called primary key. That means I am saying employee ID should be my primary key. That means none of the rows can have the similar employee ID, right? So let me create the table first, right? Table created. Now I will add a insert statement, right? Right. So insert into employees, right? Employee ID, first name, last name, right? And I am adding value 1, John Doe, right? So this will insert because we don't have any value in which employee ID is 1, right? So I will run this one. Okay, this will work. Now what I will do is I will add one more value in which first name is Jane and last name is Smith, but the employee ID is 1. We already have inserted a value 1. Now I'll try to insert the 1 again, right? Let us see what happens. Of course, it will give error, right? Duplicate entry 1 for key, employees not primary. That means it is clearly saying this primary key has a duplicate entry. Now, if you add this primary key, never ever you will have a situation in which you have the employee ID repeated, right? Now, if I have to insert this, I have to make it as 2 or 3 or 4, whatever you want. It need not be serial, but it always have to be unique or different, right? Now it inserted, right? Now I'll run the select star from employees, right? If you see ID1 and ID2. Now if you see, we have got a key symbol here. Earlier it was not there, right? If you remember, or if you want to go back to the video again, and you can see earlier we didn't have this key symbol. Now this key symbol specifies that this employee ID is a primary key, right? Very important. Primary keys are very important when you are designing your database, right? What it does is make sure you don't have duplicate entries in your column, right? So we will check the next constant, that is unique constant. Somewhat similar to primary constant only. Here what you have to do is the column should always have unique values, right? It cannot repeat. Sounds something similar to primary key, but we'll discuss what is the difference, right? But here we will check what is the syntax, right? So what I will do is I'll drop table once so that I can recreate it with new syntax, right? So I'll drop this one, so I can click on this execute. It will drop the table, right? Now we will check the create table syntax, right? So as usual, create table int. Maybe if you want, you can add primary key, that's fine. Email should be unique. That means no two people can have the same email ID, right? Then as usual, we have first name and last name, right? We will execute this one, right? Table is created, right? Now I have insert statement, right? If you see the insert statement, this email ID is repeated, right? So I'll first insert this one, execute. So by now you already know the insert statement, right? So that's why I'm just copying and pasting it and running it, right? So it inserted one row. Now the primary key constant is fulfilled here, right? Because this is 1, this is 2, this is not repeated. But if you see, email is repeated here, right? So I'll now try to execute this one, right? It immediately gave me error, duplicate entry for key employees email. That means employees cannot have duplicate email, right? So for this, what I have to do, I have to fix this one. I have to make it different. Jane Smith, right? Now if I execute this one, we will be able to insert it, right? Now you will ask, both primary key and unique key are serving the same purpose, right? So what is the difference? Two major difference that I have understood till now, or that I have experienced till now. Primary key is something that is unique within your table, but it is used as a reference to another table with something called as a foreign key, right? If you want to establish something as a foreign key in your table, you have to mark it as primary, right? Whereas uniqueness is only within the table, right? You can have multiple fields that are unique, but as such it has nothing to do outside of the table. Later on we will see there is a concept called foreign key, in which one primary key is referenced as foreign key in another table. For example, you have seen salary. Here in employee, I have only employee ID, email, first name, last name. Now, if I have to store salary, what I will do? Either I can attach few more columns into this table, or I can create another table called salary, in which I'll store salary as well as the employee ID, the corresponding employee ID from employees table. Here, if you see in employees table, employee ID will serve as primary key. In salary, when you come, this employee ID from employees table will serve as a foreign key. So I will map salary, in which there is a column called employee ID and its corresponding salary. So this is one use case in which you have to use primary key because you have to create a mapping, right? And you cannot use unique key here because it has to have a mapping, right? Another difference is, of course, we'll learn foreign key later on in the course, but for now, you understand that it creates a relation between two tables. Let's say we need primary key, right? Another scenario is primary key are automatically indexed. Okay, what is the meaning of indexing? Of course, we'll learn later in the chapters, but indexing helps us in doing better search, right? It creates index so that the search hits are less, right? The search time is less, right? So primary keys are automatically indexed. Of course, we can index other columns also, but primary keys are by default indexed. That means when you run a where condition on a primary key, that means where say employee ID equals to 2, it gives efficient result because primary key is indexed compared to searching it with email, because this is still unique but is not indexed, right? Primary keys are by default indexed. I hope that makes sense. If not, once you learn what is foreign key and what is no indexing, you can come back to this chapter and see this section again. Then I think I'm 100% sure it will click into the mind, right? Why we need primary key as well as unique key, right? Right, now we will check the next constant, that is check constant, right? What is a check constant? Check constant comes into picture when I'm trying to insert some data, and on that I can add a validation, right? If you see the example, I have a create statement, right, in which I'm creating student table. Here the normal drill, like that what we have seen, student ID, which is a primary key, name is a varchar, age integer, and here comes the check constant. Oops. Here comes the check constant. That means check if age is greater than equal to 18. If not, throw error. We don't want to insert any row in which age is less than 18, right? Right. So I will execute the table statement first, create table, right? So I have created the table, right? Now I'll insert a row, right? So 20 20 I should be able to insert because this is greater than or equal to 18, right? Okay, it happily inserted, no problem. Now 16, will it be able to insert? Let us see. No, no, right? Check constant student check is violated, right? That means this check constant came into picture, and we don't want to insert any student age less than 18. This is what check constant is all about, right? Next constant, that is default constant. Now what is the default constant? Very simple. When we are trying to insert data into the table, it is possible that at that point of time we might not know few entries. In that case, I want to have a default value. If I don't send a value, add that value always. That's the meaning of. Let us take an example, right? We have a create table products, right, which has a product ID, name, Right, till now this should be clear. Product ID, integer, primary key, name varchar of 50, right? Price is decimal, 10 2, we have already discussed decimal, right? And here I am saying default 0.0, right? That means if I don't provide the price, keep it 0.0 instead of null, right? So I will first run the table, right? Table is created. Now here is the insert statement. Insert product ID as 1, name as some name widget, right? And here I am not passing the price, right? Now of course I'll be able to insert, right? Insertion has happened. Now let me do a select on this one and see what value we get, right? I did not insert 0.0, I just skipped it. If I do not add this value here, it would have been null, but I don't want a null, right? I want some default value. If I don't provide, always add the default value. So here it defaulted to 0.00. That is the whole concept of a default value. You can add a default value in any of the column, right? So if that column is not provided, it will always take the default value, right? Okay. The next constant is not null constant. That means for a particular column, I cannot have null value. I always have to provide some value. It can be unique or it necessarily not be unique. It can be repeated, but it always have to have a value, right? Without value, the insertion will not work, right? So we'll take example, customer table, right? Customer ID, integer, primary key. We all know what is this, right? Email, varchar, unique. We also have seen this one. This one name varchar 50, and after that I am saying not null. That means I always have to provide a value for name. So let me execute this one. Right? Successfully executed, table is created. I will run an insert statement in which I'm giving customer ID, name and email, right? So this should work and it will work. Okay, right? Done. Now what I'm doing is insert into customer ID and email. I'm not providing name, right? Name is missing here. If I try to run this one, we will get immediate error. Field name doesn't have a default value. Now, why it is saying it doesn't have a default value? Because it says it's not null. So it is trying to look for a default value. If I have not provided a default value, it is looking for a default value because the database engine cannot insert null into this one, right? That's why it is giving this error. That is the whole idea of having a not null constant. You cannot insert null into this. You always have to give a value. It need not be unique, right? But it has to have a value. Now we will move to the next concept, that is auto increment field. Now what is this? Till now we were seeing that employee ID and we are passing as 1, we are passing it as 2, or maybe student ID, we are passing it as 1 and we are passing it as 2 and so on, 3 4 5, like that, right? Which becomes hectic at some point, right? Because every time I insert, I have to see what was the previous row number that was inserted, and after that I have to add that value, right? To overcome this, what we have is auto increment field. That means I don't have to provide the value for employee ID. It will automatically start taking from 1 2 3 4 like that. Okay, here create table employees, employee ID, integer. Then we have already seen primary key. On top of that, I am saying auto increment, and these two are normal, right? First name, last name, varchar. We have already seen this one. So I will execute this. Okay, employee already exists. So what I have to do is I have created this previously. So I will say drop table employees. Right? I will execute this one. That's fine. Then I will run this one with the new schema. Right? So now it has inserted it as auto increment field, right? Now I have two insert statement here. If you see values, I'll bring it down, values. Okay, right? If you see here, I am giving first name, last name. Here also I am giving first name, last name. I am not giving the employee ID, right? Since this is a primary key, I always have to give a value. Otherwise, it will throw error, right? In the same line, I am saying it as auto increment, right? That means start from 1. The next time I insert 2. The next time I insert 3. So I'll say execute, right? And I will execute the second statement also. After this, I will run a select statement. Select star from employees, right? And I will run this one. We will see what happened. First name, and last name, 2 rows were inserted. But if you see this employee ID, it was automatically inserted, right? As 1, as 2, right? This is the concept of auto increment. There might be some scenario where you don't want to add the serial number integer 1, 2, or 3 or 4 like that. We have another concept called UUID, or universally unique identifier, which is I think 36 or 38 characters long, which consists of digits and numbers, right? So I'll give you the example for that one, right? So what I have done is created a table called students plural, okay? So ID varchar, and it is a primary key. Till now we understand this much. Here what I have added is added a default condition or default constant, in which the default value will be a unique ID generated every time. This is a function call. So every time I do insertion, this function will be called in the default parameter, right? And it will be inserted into the table, right? So let me create the table. Table is created, right? Now I'll try to insert few data, right? So I'll say execute this data, execute this data also, right? Now I'll run a select statement on this one. Here, if you see, we have this unique ID. This is global ID or UUID. This is also a type of data that often you will see in production database or in real world database. Okay, instead of having 1, 2, 3, 4 numbers, we have this kind of unique identifier, right? So this is all about UUID as primary. So next we will start with date and time functions. So we have already seen some string functions, right? And similarly, we have few functions that works specifically with date and time. So let us start checking that. So I have a table here called events, right? Event ID, which is a primary key, auto increment key. By now you already know what primary key means and what auto increment means, right? We have an event name, right? Event date, time, and date time. 3 fields. Event date is of type date. Event time is of type time. Date is the date. Time means hours and minutes and seconds, like that. And date time means both, which constitutes the timestamp. That means at what date and at what time. Together, if we have to represent, we have to say date time. So we have a date data type, just like how we have varchar, we have int, we have boolean. In the same line, we have date as well as time as well as date time. Right now, what I will do is I will create this table, right? I'll execute this one, right? Now let us try to insert some data into this. So what I have already done, insert into events, right? What I will be entering: event name, event date, event time, and event date time, and values, right? Now I'll start entering the values, right? Say, let us say, for example, meeting. There is a meeting, right? At what timestamp? So for that I will say cur date. That means it will give me current date, right? This is a function, right? In the same line we have cur time. That means current time, right? And I'll say now. This will give me both date time, right? So cur date, cur time, and now. Current date, current time, and now. So this function will give me the current timestamp or the current date. This will give me the current time, and this will give me the current time and date and time, both the timestamp, right? So if I run this one, it has inserted, right? Now I will remove this one. I'll say select star from events, right? Let us run this one, right? So if you see, we have date, that is today's date, time, and date time, right? That is combination of both, right? Now let us learn few handy date time functions on this one, right? So we have this event date, right? I want to know on what is the day name of this date, right? Monday, Tuesday, Wednesday, what is the day name for this one, right? So what I can say, select, right, event name, comma, I'll say day name of event date, right? And if I run this one, if you see, meeting is on Saturday. This makes it more readable and very handy for non-techie users, right? If you have to generate a report, maybe you can consider using this one, right? In the similar line, we have another function called day of month, right? Let us see what result we will get. 13. That means this is the 13th day of the month, right? Right? Now we have another function, day of week, right? That means this is 7th day of the week. It was Saturday. I think it's starting from Sunday until Saturday. We have 7 days, right? Okay, let us take one more function, month name, right? On what month name does this event date occurs, right? That means it occurs in January, right? Very simple, right? Now we will check date addition and date subtraction, right? So I will say date add, right? Date add how much? I will say interval 7 day. That means what this will do, it will add 7 days to this event name, right? Now if I run this one, we'll see what happens, right? So if you see from the current date, it added 7 days, right? Now I already have 7 days add of the time, right? In the same line, what I have, date diff, right? So I'll come here, date diff, right? And let us say from now till event, how much time is left, right? I'll remove this one, and this is date diff, no underscore, okay, right? So 0 days, because when I did insertion, I used the now function, right? And the same date is today's date only, right? And today only I'm using now for date diff. That means it is showing 0, right? Now, so that is the date diff function. It will take difference between two dates, right? Now let us see another concept called alter table, right? What does alter table will do? It will alter the properties of the table in some way. That means either we can add a column, we can remove a column, right? We can change the property of a column. Maybe if we want, we can change the name of the table also. So we will check one by one example for that. That is alter table, right? So for that, what I will do, we'll create one table and we'll start playing around with that, right? Very simple. So I have created a table called products, product ID, name, category, price, and stock. We have these many fields, right? Let me run this one, right? So it runs successfully, right? Now I'll remove this one. I will add a table description, right? Products, right? So if you see, I have this table description here, right? Product ID int, right? Primary key, product name, category, everything is displayed here about this products table, right? So first thing, what I want is I want to add a new column, right? I already have 5 columns. I want to add another column, right? So how can I do that? For that, I'll say alter, right? Table, which table? Products table, right? What I have to do? I have to add column, right? And what is the column name? Say for example, manufacturer, right? And what should be the type? Let us say varchar 200, right? So what I added here, I'll just swipe it a little bit away. So alter table. Which table I have to alter? Products. So alter table products. What I have to do? Add column name, or sorry, add column manufacturer, right? Which is of data type varchar 200, right? Now I will execute this one, right? So if you see success, now if I say describe product, you see I got one more column name, that is manufacturer, right? So we will take another example. I have to modify a existing column, right? So for example, price is a decimal, I want to convert it into integer, right? So what I will do? Alter table products, right? Instead of add, I will say modify. Modify which column? Modify price column, right? And convert it to integer, int, right? Now price is showing as decimal, right? Now I will execute this one, and I will execute product describe. So now if you see, price is updated as integer, right? So what I did, alter table products, modify column price, then new data type, right? So this is how we can do column modification, right? Next example. Now what I have to do is I have to rename the column, right? First I added a column, then I changed the type of the column. Then what I want to do is rename a column. So I have a stock quantity column. I want to change it to stock count, right? So what I'll do, alter table products, that will remain constant. Right here, what I will do, change column, right? I have to do change column. Change column, which column I have to change? Stock quantity, right? And I want to convert it to stock count, and I have to give data type, right? Maybe instead of only changing the stock count or renaming the column, I can change the data type also, but for now I'm keeping it constant from change column stock quantity to stock count, right? I will run this one, right? It changed. Then I will do describe product. So now it is showing stock count, right? So I changed the column name. Now another next scenario, right? This product ID is of primary type. I want to remove this product ID as a primary type, right? So for that, what I will do, alter table products, I will say drop primary key, right? I'll run this one. Now if I do execute, this is no longer a primary key product ID, right? What I want, I have to bring the product ID back as a primary key, right? So what I can do, add primary key, and which column I want to make primary key? Product ID, right? Alter table product, add primary key product ID. So I will run this one. So what this will do, add product ID as the primary key, right? So I'll run this one, and I'll do describe product, right? Now it has again become primary key, right? Now if you remember, few columns we can add a default value, right? Now we don't have a default value yet for, say for example, manufacturer. Now I want to have a default value for the manufacturer. Every time somebody adds a manufacturer or somebody adds a row, if they don't provide the manufacturer value, we will say unknown, right? So what we will say, what we will do, alter table products, we will say alter column, right? Which column? Manufacturer, right? Set default as unknown, right? So if you see here, default value is null, right? We'll check after executing this query what behavior what changes have happened, right? So alter table products, alter column, manufacturer, set default unknown, right? So I will execute this one, right? It is executed. Now I will run the describe block. If you see manufacturer, it is now saying unknown, right? That's how I can add a default value to a column, right? Now what if I want to drop this? Possible, right? Yes. So I'll say alter table products, alter column, manufacturer. Instead of set default, I will say drop default. And anyways, I don't have to pass this anymore, right? Drop default, right? Now I'll run this one and I will run the product describe, right? So if you see manufacturer, the default value is back to null, right? And we also have studied about constants, right? So can we add a constant here? Say price should be greater than 10, say for example, right? I don't want any product whose price is less than 10. So can I add a check constant, right? What I can do is add, right, on price greater than 10, say for example, right? I'll run this one, right? So that will add the constant. Now the next example, can we rename the table? Yes, if I want, I can change the product to some other table, right? So what I can do, alter table products, right? I'll say rename to, say for example, inventory, right? I will run this one. So table name changed. Now if I do describe product, will it work? It says product doesn't exist or products table doesn't exist. So what I will do, oops, I'll use inventory, describe inventory. So I'll have the same result, right? That's how I can change the table name itself, right? So that's all about alter tables. So the next concept that we will start is foreign key concept, right? So what exactly is a foreign key, right? So till now we have been using single tables for all our examples, right? Now at some point what we have to do is create multiple tables in order to store the data, right? So say for example, I have a customers table, right, which has customer ID, customer name, and contacts. Right now, I want to have a orders table in which I want to store which customer ID ordered on which date. Right. So if you see here, I have, this is the order ID, right, which is a primary key for the orders table. After that, I have a customer ID and order date, right? So this customer ID is nothing but the customer ID from the customers table, right? This is what it represents. That means this customer ID on customer table is the primary key, and that column, when it is referenced in another table, that is called as a foreign key. So this customer ID in orders table is a foreign key to the customers table's customer ID column, right? So this creates a relationship between these two tables. That means this customer ID on orders table references customer ID from the customers table, right? On customers table, this customer ID is the primary key, and on the orders table, this customer ID is the foreign key, right? That is the whole concept of a foreign key, right? So we'll take some example and we'll see. Right, so here we have a department table, right, which has a department ID and a department name, right? So I'll create the table first. Okay, a table is created. Now in employees table, if you see, I have employee ID, employee name, and I have this department ID, which refers to this department ID in departments table. That means this employee belongs to which department is stored as department ID in this table, in employees table, and this department ID refers to department ID in departments table, right? Now how I have established foreign key relationship? I'm saying foreign key is department ID. This department ID is this department ID in the employees table, right? So foreign key is department ID, which references department's table department ID, right? So this department ID is this department ID, right? And this department ID belongs to this table department ID, employees table department ID. So foreign key department ID references which table? Department's table department ID, right? An important thing is the two data type should match, right? We cannot have a varchar here and an integer here to create a reference or a foreign key reference, right? Now if I run this one, I'll be able to create the table, right? Now we will insert some data into the table, right? So here I'm inserting some data into the departments table, right? ID1, then department name, ID2, department name, ID3, and department name, right? So I'll execute this one. Then on employees table, what I'm doing, this is employee ID, employee name. This is the department ID which refers to this department ID. That means this user ID1, or sorry, employee ID1 Alice belongs to department 1, that is HR department. Similarly, if you see Charlie, the ID is 3, department ID is 3. That means this 3 belongs to this IT department, right? So if I execute this one, I'll be able to execute this, right? Now if I do select star from employees, right, I'll get employee ID, employee name, department ID, right, and its salary. So this department ID is nothing but a foreign key to the department's table department ID, right? Now the obvious question comes is, why do we need this foreign key reference, right? Even without reference, I should be able to, or I will be able to enter this 1 and this 2 and this 3 and this 1 and this 2 in the employees table, right? This will not stop me from entering, right? But then what is the whole idea of having a foreign key, right? As such, it won't stop me from entering data, right? So I'll be able to enter data freely, right? I should be able to enter anything in this column, right? It may refer to another table, it may not refer to another table, but I should be able to independently enter the data, right? So why do I need to have a foreign key here, right? Now to show you why we need a foreign key, I will try to insert an employee with a ID, with a department ID that doesn't exist here, right? So if you see what I'm doing, insert into employees, employee ID is 6, from here it is 5, so I have added 6, employee name, right? Now department ID is 4, I'm trying to enter, and some salary. But if you see, we don't have a department ID 4 here in our department table, right? What will happen if I try to insert this one, right? Now before I tell you what happens, now just imagine if somebody is trying to take out a report in which what he is trying to do is he's trying to find all employees and their department, right? If we don't have a foreign key relation, we will be able to insert this data, but the moment in which we try to find the department of employee ID 6, we will get null, right? Which is not desirable, right? This is kind of a corrupt data. We don't want to have employees without a department, right? So this way our data will be corrupt. So if I am able to insert this, then that is wrong. That destroys the integrity of the database, right? So if I try to execute this one, right, of course it will throw error, right? Because this employee ID, sorry, this department ID 4 doesn't exist. That's why I have to have a strong foreign relationship so that it will prevent this kind of error data entry, right? This is what is called as referential integrity. That means if my table points to another table's key, I should not be able to insert a data that doesn't exist on the parent table, right? Otherwise I'll end up in corrupt data, right? Which is not the state I want my database to be in, right? So if I have a strong foreign key relationship, this kind of error will be quickly prevented, right? So that's why we need a foreign key relationship. Otherwise I will be able to enter the data even if say for example 4 is not available in the departments table, right? But the question comes on the data integrity, right? I will be able to enter haphazard data into the database, right? So I need a strong relationship between database. That's why it's called relational database, right? That's when the concept of RDBMS comes into picture, right? So that's how I create relationship, and that's how I prevent data from losing its integrity, right? Okay, now we will take this scenario, right? What I'm trying to do is delete department ID 1, right? Now department ID 1 is human resources. I want to delete the department, right? The problem is, in my employees table, there is at least one row which refers to department ID 1. If I delete the department ID 1, again my data will be in corrupt state, right? Because when I try to run a report on Alice or David, which department they belong to, I'll get null data, right? Which is not what I want, right? So now if I try to delete it, it will throw error saying that cannot update or delete a parent row. Why? Because this row is referred in employees table, right? That's why I created a foreign key relationship. This will not allow me to delete a parent row if the department ID or the column is used in another table, right? Now what is the solution for this one? Of course, the first solution is I'll go manually into the employees table, right, and delete all employee ID or employee ID in which the department ID is one. That is one way. But there is a possibility that this department ID may be a parent to maybe 10 or 15 number of tables, right? This is just a dummy tutorial scenario. That's why we have only 2 tables. But in real life, you might have 10 or 20 tables of which there is a single parent. Possible, absolutely possible, right? In that scenario, you cannot go into each and every table, delete the child and delete the child from each table and then come to parent table and then try to delete. Not possible, right? So for that, what we do is there is a statement called on delete cascade, right? We will see how it is used. So for that, what I will do, I will delete the employees table, right? And we will recreate it with the new condition, right? I'll keep the departments table as it is, right? Now, so what I'll do, I'll try to recreate the employees table. But now if you see, everything is same. Here also I'm doing foreign key referencing to department ID from departments table. And here what I'm doing is on delete cascade. That means if the primary key is deleted or if the key on the parent is deleted, delete the child row as well. That's what this means, right? That means if I try to delete a department ID 1 from the departments table, on the employees table as well, all the rows that have department ID 1 will also be deleted, right? So I'll execute this, right? After this, I'll try to insert the data, right? I'm able to insert, right? Now, if I do select star from employees, right? So we have one person called Alice with department ID 1 and one person called David with department ID 1, right? Now what I will do is I'll try to delete department ID 1, right? Now in employees table, I have 2 rows which points to department ID 1, right? So I'll delete this one. This time delete succeeded, right? Delete succeeded because this time it also deleted the rows from employees table as well, right? Now if you see, we don't have employee ID 1 anymore, we have 2, 3 and 2, right? So that's what this statement does on cascade delete. That means if the parent department ID is deleted, delete this row as well. That's what on cascade delete means, right? Now we'll drop the employees table again and we'll look into the next concept, right? Okay, this was about deleting the parent key, right? Now what if I want to update the parent key, right? What if I want to update the parent key? That means I'll delete the department table also. We will again start from scratch, okay? Right, so if you see here, departments table, same as department ID and department name, right? Here employee ID, name, department ID. This department ID is a foreign key to the department ID, right? And here if you see, it says on update cascade. That means if the parent ID or the parent's department ID is updated, update the child department ID also, right? So we'll check the example. We'll execute this one, we will execute this one, right? And what we will do, we'll insert few statements, right? So department value, what I am entering, 1 HR, right? Then I'll insert 2 more into the employees table, right? So ID, name and department ID, right? Both of them points to department ID 1, right? Now I'll say select star from employees, right? So here department ID is 1, right? Very simple till now. Now instead of deleting, what I am doing is I'll update. Okay, what I am doing here, update department ID, update departments, set department ID equals to 2, where department ID equals to 1. That means this department ID 1 HR, I am changing it to 2 HR, right? So I will, and before that, let me show you select star from departments, right? Let's see. So we have 1 HR, right? What I will do is I will update. I'll run the update statement, right? It updated. I'll see the department table. Here, if you see, this has become 2, right? But in our employees table, we have this 1 and 1 as the key, right? Now, because of the on update cascade statement, what will happen is if I run select star on employees, this 2 also has been updated, right? That's the idea of on cascade update, right? If the parent column value is updated, the child row value or the child value or the child column value will also be updated accordingly, right? In the same line, on cascade update, on cascade delete, we have another functionality called on delete set null. That means if you try to delete the parent, the child row will not be deleted, rather it will be set to null, right? Right, so we'll take a example of that one, right? So I'll delete my table. See, for tutorial purpose, I'm doing always delete and creating the new table, right? In real world, you don't drop table like this, okay? For that, we use alter statement, right? For ease and for convenience and for better example, so that I'll be able to give better example, I'm doing the drop and creating the table again and again, right? So same department table, right? I'll execute employees table. Here foreign key that we have already seen, department ID references departments, department ID. Here what I'm saying, on delete set null, right? I'm not saying cascade delete. What I'm saying is on delete set null, right? So I will execute this one. This is created, right? Now I'll create the one single column in department table and 2 column in employees table, and they refer to this department ID 1 from here, right? Right, now what I will do is select star from employees, right? I'll run this one. So if you see, a department ID is 1 and 1, right? Now what I will do, I'll delete this one, right? Delete from departments where department ID equals to 1, right? I will delete this one. This is deleted. Now what would happen to the employees table? Here I am saying set it to null, so it will set it to null. Earlier, if it was on cascade delete, it would have deleted the employees row, but instead of that, now it has set it to null, right? Now can we add multiple conditions? Of course we can add multiple condition, right? So what happens when we delete and what happens when we do update, right? So if you see here, this is the same foreign key reference, right? Referenced to departments, department ID, right? And on delete cascade as well as on update cascade. That means if you delete it, the row will be deleted. Also, if you update it, the child row will also be updated, right? So here I am using both the condition. That's how you can use both conditions, right? So the next concept that we will see is relationship and join, right? Most important concept in database management system, right? And we will start checking into that one. So the first relationship that we will check is a one-on-one relationship. That means one row in a table can have only one corresponding mapping into another table, right? So if you see the example here, I have an employees table and I have a contacts table, right? In employee table, I have employee ID and employee name, right? And on contacts table, I want to store employee address and employee's email, right? Now, if you see in employees table, I can have only one record in contacts table that matches the employee ID. Why? Because one employee can have only one address and one email address, right? That's what logically makes sense, right? So in employee table, only one row can map to another row in the contacts table. So this is what is called as a one-on-one relationship. So we will check example for this one, right? I'll delete all my tables as usual. I will start again from clean slate, right? Right now, if you see this table, we have an employee table or employees table, employee ID, name and hire date, right? That's fine. And in employee details table, we have employee ID, we have address, we have contact, and there is a foreign key. Foreign key, which one is the foreign key? Employee ID here is the foreign key, which references to employees employee ID. That means this employees employee ID is referenced as the foreign key here in employee details table, right? So what I will do, I will create this table and I will create this table as well, right? Once that being done, what I will do, I will add some data into this one, right? So execute, right? Now I'll say select star from employees, right? And I'll say select star from employee details, right? Now what I have to do is I have to individually run this one, right? So if you see employee ID 1 Alice and hire date, right? And employee ID 1, this is the address and this is the contact number, right? Now what I have to do is I have to pick data from two different tables, right? That's when the concept of join comes into picture. What does join do? It will join two tables, right? How can I join two tables? We will see the example, right? Now what I want is I want to display employee name, employee name from employees table and its corresponding address and contact name from employee details table, right? So what we will do, we will say select, right? Select what? Select, because now we are dealing with two tables, right? So when I am giving the column name, I will specify it with table name as well. So I'll say employees dot, I want to filter employee name, right? I will bring this to this line, right? What else I want to get? I want to get employee details dot address, and I should add one comma here, right? And employee details dot contact number, right? Now from which table? This is available in two different tables, right? So for that, what I will use? I will use join. So from employees, right? Join employees detail. That means instead of saying from employees, what I am doing is I am joining two tables, and with that I am saying from. That means select employee name, address, contact number. Now since this data is scattered across two tables, that's why what I did, employees join employee detail, right? Now based on what it will join? Based on the employee ID that is available in both the column, right? So what I will do, select something from employees, join employee details on, right? Employee employees dot employee ID equals to employee details dot employee ID, right? Join on what? Join on employees employee ID. So if you remember the table, in employees we have a employee ID. On employees detail also we have a employee ID as a foreign key, right? So what I will do, join employees and employee details on employee ID, right? Employee ID once from employees table and from employee details table, right? Now if I run this one, you will see here Alice, first main street, then contact number, right? These two data are coming from two different tables, right? This is what join helps us in achieving, right? This join is actually also called as inner join, right? By default it takes inner join. So if I do inner join, I'll get the same result, right? Now we'll understand the concept of left join, right? Now to understand that, what I will do, I will add another value into the employees table, right? But I will not insert its corresponding employee details, right? That means employee details for employee ID2 is empty, right? So to show you that, what I can do is select star from employee details, right? We have only one entry, right? Now if I do select star from employees, right, I have two entries. That means this ID2 doesn't have a relationship row on the employee details table, right? Now if I do inner join now, what result I will get? I will get only one result, right? Now instead of inner join, if I do left join, now what exactly left join will do? Left join will do, now what is the meaning of left here? Left means this employee table is the left, whichever we write first, right? The employee table is the left and this employee details table is the right table, right? So when I say left join, that means it will pick up everything from employees, and on employee details, if it doesn't have a corresponding mapping, it will keep it as null, right? So now I have changed it to left join. Now if I see the result here, I got Bob also. That means it will give me everything on the left side of the join from the left table of the join, even if the corresponding right part is empty, right? Now if I say inner join, what will happen to this Bob? This will not come into result. Inner join will take only what is available here on the left side of the inner join, on the left table of the join, as well as on the right table of the join. Whatever is common, whatever is exactly available, it will take, right? Now if I change it to left join, it will take everything from the left side of the table, and on the right side of the table, if the corresponding relationship is not available, it will keep it as empty, right? That's the concept of left join, right? On one-on-one relationship, right? Correspondingly, we have another relationship called one-to-many relationship, right? This is what one-to-many relationship would look like. So we have an employee table and we have an attendance table, right? One employee can have multiple attendance for multiple days possible, right? So if you see employee ID1 has, for example, I have given 3 attendance date, right? Similarly, this guy, the second employee ID, has also 3 corresponding rows in the attendance table. That means one employee can have many attendance. That's what it means, one to many relationship, right? One employee can have multiple attendance. That means here, this being the foreign key, can occur multiple times. Here 1 1 1 and here 2 2 and 2, right? So this foreign key appeared multiple times between in the attendance table, which corresponds to employee table, right? So this is the concept of one to many relationship, right? So as usual, I'll do everything, I'll delete everything, right? We'll start again from scratch. Usually you don't do that in production, but for learning purpose, I'm deleting the table and creating it again and again, right? So here, what I'll be doing is, I'll show you one to many relationship. right? So I have an employee table and I have a daily attendance table, right? So employee ID here is primary key and employee name, right? And attendance ID is the primary key here, right? So if you see, we'll take the example now. So we have the employees table and the daily attendance table, right? Employee has employee ID and employee name, right? It has attendance ID, its primary key and the primary key of this table. Then we have employee ID, which corresponds to this employee ID. Then we have attendance date, we have status and the foreign key relationship, right? So I'll execute this one. Here I have to remove this one, right? That's why it gave me error. So I'll execute this one, right? And I'll also execute this table, right? Now I'll try to insert some data, right? So this is some data. I will select all and run this one, right? Remove this, right? And I have some more data. So I'll do select all and run, right? So it will insert data into the employees table as well as in the attendance table, right? Now if we see this one, select star from employees, right? So we will get some value, right? Select star from daily attendance, right? We'll get some attendance value, right? Now the question is, what we have to do is we have to pick out employee name as well as their daily attendance, right? Of course, these two are available in two different tables, right? So for that, obviously, we have to use join, right? So we will see this one. So we will say select something, right? So first of all, what I have to do, I have to pick employee name, which is available in employee table, right? So I'll say employees dot employee name, right? Then I have to pick attendance date and its status, right? So I will say daily attendance dot attendance date and daily attendance dot status, right? Status from of course we don't have it in single data, right? So I'll say employees inner join daily attendance on employees not employee ID equal to, right, daily attendance dot employee ID, right? So since employee ID is the common field or the common row that combines employee and employee details, so I'll run a join based on employee ID, right? So here what I did, employees dot employee ID equal to daily attendance dot employee ID, which inner joins employees table and daily attendance table, right? And this will pick up employee name, attendance date and attendance status, right? So if I run this one, right, if you see, we have Alice, then Bob and Charlie and Charlie, these three field along with the employee name coming from employee table and attendance date and attendance status coming from daily attendance table, right? So this is example of one-to-many relationship, right? Now here I have added normal select statement for individual table, right? So if you see here, we have 4 entries: Alice, Bob, Charlie and Sam, right? Here if you see, in attendance table we have employee ID 1, 2, 3, but we don't have employee ID 4, right? Employee ID 4 doesn't have any attendance record, right? Now if you see this one, this is doing inner join, right? So if I do inner join, if you see the result here, I don't have the 4th person, right? Because in inner join it will only filter the left and right table matching rows, right, which are completely matching, right? Instead of inner join, if I say left join, right, what will happen? You will see you get the result, that is the 4th employee ID, but its corresponding attendance and status are null, right? So this is what left join will give you, and inner join will give you, right? This is the main difference and very important interview question. So till now we have seen one-to-one relationship as well as one-to-many relationship, right? Now we will take it up the notch and we will see many-to-many relationship, right? So we will take one example and we will understand. Okay. So here if you see we have a student table and we have a course table, right? It is possible that a student can take multiple courses, right? Also, a course, one single course can be taken by multiple student, right? So to achieve this, what we use is called a bridge table, right? If you see here, we have a student table and we have a course table. Here, there is another table called enrollment, which has a enrollment ID, which is the primary key for the enrollment table, which maps student ID versus course ID, right? So if you see here, student ID 1 has taken course 101 as well as student ID 1 has taken course 102, right? Now if you see from here, 101 course is taken by student 1 as well as 101 course is taken by student 2. So one student can take multiple courses and one course can be taken by multiple student, right? So that is the concept of a many to many relationship, right? Now we will take example and we will dive deep into this one, right? So we will take an example and we will try to understand this, right? So I have created a authors table and I have created a books table, right? So the idea is a author can have multiple books, right? And a book can be written by multiple authors, right? Possible. So what we will do is we will execute this one and we will execute this one, right? Now I will try to create the bridge table, right? Which maps book ID with the author ID, right? So this is the books authors table, right? Which has a book ID and an author ID, right? Here, this is important. This primary key, right? The book ID can occur multiple times in the column, right? Because it's a many to many relationship. Similarly, author ID can also occur multiple times. But what uniquely identifies a row in this table is a combination of book ID and author ID. That's why this is a primary key in which the primary key is the combination of both book ID and author ID, right? Because these two column can uniquely only identify a particular row in this table, books authors, right? And we have a foreign key. The book ID is a foreign key to the books table and the author ID is a foreign key to the authors table, right? This foreign key relationship we have seen previously, right? So I will execute this one, right? Now here in the authors table, I am adding three values, right? So I will select all and run, right? I'll remove this one. Similarly, I am adding few three values into the books table, right? So I will select all and run, right? I have inserted data, right? Now I will insert some data into the bridge table, right? So if you see here, insert into books authors value book ID. This is coming from author ID, right? Book ID, author ID, right? So if you see this book ID occurs multiple times, right? That means this book is written by author ID 1 as well as author ID 2, right? And if you see author ID 1 has written one book as well as author ID has written another book 103, right? That's what constitutes the many to many relationship. A book can have multiple authors and author can have multiple books, right? So I will select all and run, right? I'll remove this one. Now my book table exists in a different table, the author exists in a different table, and their relationship is maintained in a different table, right? Now what I have to do is I have to display the author ID with respect to the book ID or the author name with respect to the book name. Now since the data exists in three different table, I have to use two different joins, right? So we will check one by one how we will get the result, right? So my target is, for each author I will display the corresponding book names, right? That is what is my end result. So for that, what I will do, of course I have to do select. What I will select, I will select authors dot author ID, right? And authors dot author name, right? Also, what I have to do, I will go into the bridge table, and for each author I will try to print the book ID, right? So I will say authors books, okay, it's books authors, right? Books authors dot book ID, right? Because I want to display the author ID as well as book ID. This book ID corresponding to the author ID is available in books authors table, right? So I will say from, right? I will have to join now authors, inner join books authors, right? On authors dot author ID equals to books authors dot author ID, right? Now if I run this one, there should be a comma here, there should be a comma here, right? So if I now run this one, you will see author ID and author name is coming from authors table, right? This book ID 101, book ID 103 is coming from books authors table, right? Because that's where we have the mapping, right? Now instead of book ID, I want to display the name of the book, right? So what I can do, where this value is available, this is available in books dot book ID and books dot book title, right? Now from where I will get this information, if I do another join of this result, right? So what I will do, I will say inner join, right, books, right, on books dot book ID equals to books authors dot book ID, right? If I add this one, I'll get the book details as well, right? Now as per the requirement, what I have to do, I have to publish the author name as well as their book, right? So I'll remove other fields, right? This I added just for the reference, right? So author name and book title, right? Now if I run this one, if you see, John Doe has published two books, one book and another book, right? And if you see, Data Science Essential is published by three different authors, right? That's what this many to many relationship signifies, right? So I'll explain it again. Select, right, author name and book title, right? Now I have to join two tables. One is author with books authors on author ID, right? With that I will get the book ID, because book ID exists on books authors table, right? Once I get the book ID, I will join book ID with books table so that I can get its name, right? So I have two inner joins, right? Similarly, if I need, I can use left join also. If I have to publish all the author, maybe they don't have a book yet, right? In that scenario, if I say left join, we'll get maybe one or two values here, and maybe the book title will be null, right? We have already seen the usage of left join, right? So I know this many to many concept might be a little tricky, so I have come up with another example that I will explain, right? So here we have a users table and we have a products table, right? A user can buy multiple products, right? And a product can also be purchased by multiple users, right? So that's what I'm saying here. Users table has a user ID and username. Product table has a product ID, product name, and price. Simple, right? So I'll create this user and I'll create the product, right? Now there is a table called orders, right? Now what does this order do? It has a order ID primary key. This user ID belongs to this user ID, and this product ID belongs to this product ID, right? This is the bridge table that creates the relationship between user and product, right? And we have a order date timestamp, right? And these two are user ID and product ID are foreign key to the product and user table, right? Similarly, I will execute this one also, right? So a user can have multiple products and a product can be purchased by multiple users, right? And here, what is the primary key? The primary key is order ID, right? Right here, this constitutes the primary key, right? Now we will insert some data, right? So we will insert some data into the users table, right? So I'll say execute, right? User table has some data. Product table also have some data, product ID, product name, and its price, right? So I will execute this one, orders, right? This is the order ID primary key, right? This is the user ID, product ID, and purchase date, right? This is the user ID, product ID, and purchase date. So if you see, user ID 1 has purchased 2 items, right? And if you see here, product ID 103 is purchased by user 2 and user 1. That's what is, one user can have multiple products. One product can belong to multiple users. That is many to many relationship, right? So I'll execute this one, right? This being done, right? Now what I have to do is I have to display the user name as well as the product name that they have purchased, right? So I will say select star, will not do star, okay? Select, what I have to first figure out, user name, right? So I will say users dot user ID. Let us take user ID also, and we'll display username also, right? Username, right? And what I have to display, the product ID that they have purchased, right? Because I don't have a direct relationship in which I'll get user ID and the product name that they have purchased, right? I have user ID and product ID in orders table. So for that, if I have to figure out the product name that they have purchased, for that I have to go to orders table, and for that user ID I have to get the order ID or the product ID, and again from that product ID I'll go to the products table and fetch its name, right? That will be the flow. So I will say orders dot product ID, right? From users inner join, right? Orders on users dot user ID equals to orders dot user ID, right? Now if I run this one, here I should have one comma, right? Okay, so I was getting that error because of the case, right? It should have been uppercase, right? Now if I run this one, what I will get, user ID, username, and its product ID, right? Now I have the product ID for a user ID and name. With this product ID, I will go to product table and try to fetch its name, right? So I will add comma products dot product ID, right? And products dot product name. What I will do, inner join, then what it will join on products, right? Inner join products on, right? On orders dot product ID equals to products dot product ID, right? So here the product ID and the product name, right? So I have two product ID, right? So I'll remove all of this. I don't need, and I don't even need the username, right? All I want is the user ID. I don't name. All I want is username and product name, right? Now if I run this one, I'll see John Doe has purchased laptop. John Doe has also purchased smartphone, right? And also smartphone is purchased by John Doe and smartphone is purchased by Alice Johnson, right? That's what constitutes the many to many relationship, right? I hope that is now clear, right? So the next concept that we will see is the concept of a view. What is a view? A view is basically a virtual table, right? It's not a real table, it's a virtual table. And what does that table contain? This table contains the result of a select statement, right? So if there is a particular select statement that needs to be run again and again, it's a good idea to convert it into a view. If we convert it into a view, that view will be stored in the database server, and when we call that view, the internal select statement will run, right? So here I have a select statement, right? And if I run this one, I get some result, right? That we have seen previously, right? Now the thing is, this script is always needed by the organization, for example, right? So every time you cannot type this long big query, right? Here it is a 7 line of query because this is a tutorial video. But if you are into real production, right, you might have queries, select queries that consists of 100 lines of code, right? So we cannot always keep on typing that query, right? So it's convenient to convert it into a view, and when we run the view, that select statement, that's internal select statement, that will run and it will give us the output, right? So how can I convert this select statement into a view, right? So for that, what I can say, create view, right? This is, I'll say, order details as, right? Now what happened here? Now what I am saying is create view. This is the command. This is the view name as, and I am giving this select as its input. Right now, when I execute this query or this create view code, what will happen is it will create a view for me. Right now, if you come to your database explorer, right, and if you select view, we will get a order details view, right? What can I do with this view? Just like a normal table, you can perform all operation on this, right? So I can say select star from order details. If you see the order details in the tooltip, it is saying a view as a hint highlight, right? So if I select that one, I should be able to run the view just like how I was running the select statement, right? So if I run this one, I'll get the same result from what I used to get from this select statement, right? Now I don't have to run this select statement again and again. All I have to do is call the order details as if it's a table, as if it's a virtual table, right? And from here, what I can do is I can only say username, right? All those things that you can do with a normal table, right? Adding a select condition, adding where condition, using joins, everything we can do on this virtual table as well. That is the view, right? So I'll say select star, right? And can I say where, right? Product name equals to smartphone, right? This p is small, right? If I run this one, I'll get only the smartphone. So what I'm trying to show is all table operation that we have learned till now can be done on view as well, because it's a virtual table, right? The table as such doesn't exist, but if you run the view, we will get the in internal select statements result, right? That's what view is all about. Now we will check the next concept, that is stored procedure. The problem with view is it cannot take input parameters like how we do it in a function. Also, it cannot return as a single value, it will return as a table, right? Now, for example, what I have to do is I have to write a functionality, or I have to write a store procedure in which I will pass the employee ID. It will give me a 10% bonus on that employee, right? So I should be able to pass any employee ID and I should get the output as the increased bonus amount, right? So for that, what we will use is we will use a store procedure that can take input parameters, run a select statement based on the input parameters that we will provide, maybe a where condition, right? And it will return as a output, right? So we will see how to write a store procedure, right? I'll remove this one, right? So what I will do is, for example, I'll say select star from employees, right? The employee have a salary column, right? So I want to write a procedure that will take employee ID, and based on their current salary, what will be a 10% increment on that, right? So just an example, we will create a store procedure to solve this scenario, right? So for that, what I will say, create procedure, right? And I'll give it a name. So I'll say calculate bonus, right? Now this will take one input parameter, or if we want we can pass multiple input parameters and output parameters, right? So to pass a input parameter, I will say in, right? In, right? And I'll say employee ID, which is of type integer, right? Comma out. What will be the out parameter? Out name, let me call it as bonus, which is of type integer, right? Of course we can use any other data type like decimal, float, double, like that, but for ease of understanding, let us call it integer and it should be bonus. Okay, so calculate here also bonus, right? Calculate bonus, it will take an employee ID and it will give me output the new bonus amount, right? Now what will be the definition of this procedure? It will start with begin keyword and it will end with end keyword, right? And inside this, whatever we will write, that will constitute the body of the store procedure, right? Now what I have to do is I have to calculate the bonus, right? So for that I have to run a select statement based on the employee ID, right? Now the output of the select statement, I will store it into a variable, right? So what do I mean by that? So I'll say declare, right, emp salary, which is of type integer, right? So I declared a simple variable, right? Then I will say select, right, what I want to select, salary into emp salary, right? So what I'm saying, select salary into the variable called employee salary from employees where employee ID equals to which ID? The in parameter, right? emp underscore ID, right? And finish it with a semicolon, right? So what happened here? Select salary into employee salary, which is a variable, from employees table where employee ID equals to the input parameter employee ID, right? Now I have the salary with me, right? So what I can say, set. Now what value I have to set? I have to set the output variable, right? So I will say bonus, right? Bonus right, which is equal to emp salary star 0.1. What does this mean? That means a 10% increment on the employee salary, right? And this employee salary or the EMP salary variable, which is a local declared variable, came from the select statement above, right? And the select statement has a where condition, and that where condition does a comparison based on the in parameter to the store procedure, right? If there are no spelling error, we should get the result, right? Or we should be able to create the store procedure, right? So the store procedure is now created, right? Now if you see the database explorer tree view, if you go to the procedure, you will see calculate bonus is created, right? Now how can we use this one, right? To use this one, we will use the keyword call, right? Calculate bonus, right? And I have to pass two parameters, right? One is the employee ID, for which I want to calculate the bonus, and a variable on which it will give me the result, right? Employee bonus, right? Then what I have to do, I have to select, I have to display the employee bonus, right? So for that, what I will use, select add employee bonus as, right? I can say bonus, right? So first what I will do, I will execute this one. So it called the store procedure, right? Now if I execute this one, I'll get the bonus amount, right? Similarly, if I have to calculate for employee ID 2, right? I'll execute this one, then I'll execute this one. So I'll get the bonus amount, right? So for any employee ID or for any combination of input parameters and output parameters, if I write a store procedure, I can call them with any parameter and I will get the output. So that is the whole concept of a stored procedure. So the next concept that we will learn is about JSON data type, right? So now we have seen many data types, right? We have seen strings, we have seen date time, we have seen varchar, right? In the same line, we have another data type called JSON data type, right? So what this data type helps us do is it will help us in inserting JSON type of data into our database, right? So first let us see how we can create a table with JSON data type. Then we will see how we can insert data into the JSON data type, and then we will see some interesting operations on the JSON data type like insert, update and delete, right? So let us see. So first let us see how to create the table which has a JSON data type, right? So what I will say, I will say create table, right? We have already seen this example. Then I will add a primary key to this one, right? Int primary key, right? Now I will add a data property, right? And the data type of this one will be JSON, right? And I will add one more property called grade, and I will mark it as JSON, right? And here I have to give the table name, right? So let me call it as student, right? Now what I will do, so if you see here, this is a integer primary key, right? This is the data which will hold the JSON data type, as well as the grade which will also hold the JSON data type, right? So I'll run this one, right? So if you see here, table is successfully created, right? So what I will do is swap it to this side, right? Then let us try to insert some data into this table, right? So what I will do, insert into student, right? Then what values, like what fields I want to insert, ID and data. Let me insert these two fields first, okay? I'll say values, right? So there are a couple of ways in which I can insert data into the JSON data type, right? So first is the ID, right? I'll keep it as 1. Then if I want to add a JSON data type, what I will say, JSON object, right? here I will pass key value pairs, right? So one key is name, right? The value that I will pass is John, right? Another key value pair will be age, right? And I will keep it as 30, right? How else I can insert data? I can use instead of using the JSON object, I can directly use the string notation of the JSON object, right? So let us see the example for that one. So I will say ID2, right? And I will start my bracket. I will start my quotation mark. Within this, I will add curly braces. This curly braces defines the JSON data type, right? So what I will say name, right? Colon, I will say Jane, right? This is one key value pair. Then comma, age, right? Colon, and I will give a age, say 25, right? Now, what about nested JSON? So for that, what I can do, I'll take one more example. I'll say 3ID, right? I'll add the quote marks and then curly braces, right? Here also I'll do the same thing. Name, I'll say Annie, right? And I'll say age as 29, right? And next property will be address, right? This address is again a JSON object, nested JSON object. So I will add one more curly braces, right? And here I can give a property, say city, I'll say Austin, right? And here I should end this with this quote marks, okay? Otherwise it will give syntax error, right? So if you see here, this is one way to add JSON data, that is key value pair in the JSON object, in the JSON object function, right? This is one JSON, right, that I am passing as a kind of a string, right? And here also it looks like a string, but internally it will take it as a JSON data type, right? So here we have one key value pair. This is one more key value pair. Here also one key value pair, one more key value pair. This is one key. This is the value, right? And within this, since this is a nested JSON object, so what it has another key value pair inside this address key, right? Now I'll run this one and see if there are any errors, right? So right here one quotation mark was missing, right? So I'll execute this one. So if you see here, it has inserted 3 rows, right? Now if we have to see what values are there inside this student table, what I can do, I can run a select statement on this one, right? So I will say select star from student, right? If I run the query, if you see here, we have ID 1, 2, and 3, right? And we have the JSON data, right? Age 30, and name is some value, right? Here also age and name, here also age, name, and address, right? So if I click on this one, that plus hover icon, you can see the JSON object that is available here, right? And if you see here, the grade is null because we have not inserted grade into this table column, right? Now the question is, since this data is available with us, what additional advantage are we getting if we use the JSON data type? I could have simply inserted it as a string data type, right? Which also looks like a string representation here in the table column, right? So what advantage are we getting if we use the JSON data type, right? So let us see one example for that one. Now I want to select the name of this column. So within this data column, we have a JSON object, within that JSON object, I want to get the name, right? Not as a whole JSON object string, but only the name property, right? So for that, how can I write a query? So what I can do, select, right, data, then I will use a arrow mark, that is a dash and a greater than symbol, right? Then I will use the dollar operator dot name, right, as I will say student name, right? I will do little indentation. So what I have done, this is the column name. From the column name, what I want to extract the name property. So for that, what I am doing, I am using an arrow. This is the syntax. Then within the quotation mark, I will say dollar dot name. So this dollar dot name will point to this name property, right? Similarly, say for example, let us take the age also. So what I will do, I will say data, then arrow, right? Then dollar dot age, and I will give an alias, right, as student age, right? And then what I will do, from which table? From student table, of course, right? So if I run this one, let us see what data we are getting, right? So if you see here, student name, this was actually part of the JSON object, right? But here I'm able to filter it as an individual table column, right? So student name is John and the age is 30. Like that, for each individual JSON key value pair, it has extracted the individual key and individual its value, right? So this item will be the key and these are the value, right? So this is the advantage that we are getting if we use the JSON data type. We can directly query into the JSON key value pair, right? Now, how can I access the nested property, right? So I have a nested property called address, and within that we have city, right? So now I want to extract city, right? So let us see how I will do that. So data, right, dollar dot, okay. So what is the first key here? First key is address, right? So I will say address. Then I will add one more dot to go into the nested object, and I will say city, right? As I will say student city, right? Now if you see, only the third ID student has a valid city address, right? Others don't have. So what will happen to the other two columns, other two rows? Let us see, right? So if I reduce the size of this one, if you see, I'm getting Austin for this third student. This is the data that we have added, right? Other two, we don't have we have no data for the address and the city column, right? So that's why we are getting null here. So if you have even more deep nested objects, you can keep on using this dot to extract the JSON type of data, right? Now, can I update the JSON data? Yes. So I can individually go into the JSON key value pair and I can update the JSON data, right? So let us see one example for JSON update, right? So what I will do, of course, I will say update student, right? What I want to update, I want to update the age for say ID 1, right? So what I will do, set data equals to JSON underscore set, right? This is the function name, right? Now what I want to set, like what is my parent column name, that is data. What value I want to update, so say for example I want to update the age, right? And what is the value, the value, say for example I will say 31 instead of 30, let us update it as 31, right? And what I have to do, of course I have to add a where condition, right, where ID equals to 1. If I don't add where ID equals to 1, it will update for all the rows that is available in the table, right? So if you see here, what I have done, of course, update student, and there is a where condition. This part is important. What I am doing, I am setting data. I am setting it with what? I am using the JSON set method. What this will do? It will take data age property and assign it to 31, and whatever the value, it will assign it back to data, right? So data equals to JSON set data, its age, set it to 31 for these where conditions, right? So if you see here, I have currently 30, right? Now I will run update on this one, right? So if you see, successfully updated, one row affected. Now if I run this query again, we'll see the updated JSON data, right? So let us see here. If you see, we have 31 now. Earlier it was 30. It was updated because of this update statement, right? Now let us try to play around with array type of object, right? So here, if you remember, we have a student grade, right? If I run a select star from student, you will see we have a grade data type also, that is also a JSON, right? We have a grade column that is also of JSON data type, right? So now what I want is, in this grade column, I want to insert array of grade for this particular student ID, right? So for that, I'll use the update statement, right? Update student, right? I will say set. Now set which property? Set grade, right? Equals to what? I'll say JSON array. JSON array, I'll say 90, okay, 56 and 78, right? These are some random grade values, right? If then I have to add a where condition, where ID equals to say 2, for example, right? So for student 2, I want to add a grade array, right? So I run this update statement, right? So it says one row affected, right? Now I'll run the select star from student. Let us see what happened. So if you see here, ID1 is still null, ID3 is still null because we did not add. We only add it in the ID3. Here the array items are added as grade, right? Can we do some operation on this array item, right? So for example, instead of 56, say for example, I want to update this to 65, right? So for that, what I will do, update student, right? Set grade, right? Then I will use the function JSON replace. What this replace will do, it will replace a particular index of the JSON, particular index of the array, right? So for that, what I will say, for that, what column I want to upgrade, or what column I want to update as a part of the replace. So that is grade, right? Now which index I want to update. So for index, of course, we'll use the dollar sign. Then within square bracket, we will give the index, right? So I'll say index 1. So here the index starts from 0, right? So this 90 is 0th index, right? 56 is the first index. So what I'm trying to do, I'm doing JSON replace of grade, its index 1 with new value, that is 65, right? Where student ID equals to 2. This anyways, this where condition anyways you have to give, right? So if you see here, we have 90 and 56 and 78. Now I will run this execute statement, right? It says one row affected, that's fine, right? Then we will run the select statement. So if you see here, the value is now updated to 65, right? So we have seen how we will set the data. We have seen how to update the data. Let us see how to remove the data, right? So here I will say remove, right? What I want to remove from grade, I want to remove first index, right? This third parameter is not needed. So this 65 will be removed. We will only be left with 90 and 78. So what does this mean? Update grade or set grade. Use the function JSON remove. Update grade, that means remove from grade first index. And remember the index starts from 0, right? So I'll execute this one. One row affected, right? Now I'll execute the select statement, right? So if you see here, 65 is removed. Now we only have 90 and 78, right? So we have seen how to set the JSON array, how to update it, and how to remove from the JSON array, right? Let us see how we can search within the JSON object, right? Say, for example, I want to search if there is a name called John, right? So what I will say, select JSON search, right? JSON search on which column? I'll search on data column, right? How many I want to search? So we have two options here in the second parameter, one or all. So I'll stick with one, right? So it will search only once, right? Now what I want to search? I want to search Jane, right? Let us see if we have Jane in our data column in the student table, right? From student, right? Now if I run this one, if you see here, we are getting null because in the row 1 we don't have any name called Jane. Similarly for 3 we don't have any name called Jane, right? Now in 2 we are getting the value. What is this value? This is the path in which this search string matched, right? What is the path? That means at the root level, there is no nesting here. At the root level we have a path called name in which this Jane object, this Jane key matched, right? So this will give us the path, right? So can I say, for example, 25? Do we have something called 25 in data JSON object, right? So let us search this one. This is another example. If you see here we have age, right? So 25, here age is the path to the value 25, right? Similarly, let us try for Austin. Do we have something called Austin in our database, right? So I'll run the search. So if you see here, first two are null, right? In the third one, what it says, Austin is found in address.city. This is the path. So if you are looking for Austin, this is the path you have to follow for the third ID, right? That's what this JSON search means, right? So this is what the JSON search means. It will return you the path to the value where this key is found, right? Now let us take an example of an aggregate function, right? So what are aggregate functions? We have already discussed aggregate function. So here what I want to do, I want to find the length of the grades array, right? So we have a grade column, right? And within that we have inserted a array object, right, as part of the JSON data type. So I want to find the length of the array, right? So for that, what I will do, I'll remove this one, right? I will say select, right, id comma JSON length of which property? I will say grade property as grade length from student, right? Now if I run this one, if you see here, of course it will be null because for the id 1 and id 3 we don't have anything in the grade column, right? On the second index, on the second id, we have the grade array which had two value. we had inserted 3 items, then we did an update, then we did a remove. Now we are left with only 2 items. That means that's why we are getting the length as 2, right? This is what the JSON length will give us. So can I use having on this one? So I'll say having, I'll say grade length equals to 3. So if I add this having condition, do you think we will get any value? Do we have any grade length which is equal to 3? So if I run this one, of course it will give us empty data set, right? If I say grade length equals to 2, right, I'll get 2. So this is how we can use aggregate function and having condition, right? The next concept that we will learn is transaction, right? Very important concept when it comes to database is understanding a transaction, right? Now, what is a transaction? So say for example, there are 2 or 3 number of queries that you want to run. You have to guarantee that all the query will either succeed, or if one query fails, we have to bring the database to its previous state. We cannot have one query succeeded and one query failed, right? What is a classic example of this one? Say for example, there is a banking transaction happening, right? There is a person A sending say 200 rupees to person B, right? So how database query will be written for this one? So what we will do, we will take account number of A, update its balance, set it to -200, and we will take the account ID of person B, update its account balance to +200, right? Both the operation should succeed, right? If one is succeeded and one fails, then our database will be in a corrupt state, right? So when one person sends the money, other person should definitely receive that one, right? Say for example, the person A, its database operation could not be succeeded, right? So the amount will not be deducted from his account, but the person B will get the money, right? So here the database will be in a corrupt state, right? So there are few operations in which we want to maintain atomicity. What does that mean? That means all the operations, it could be insert, update, it could be any sequence of operation, it has, all of them have to run successfully. If one of them fails, we have to roll back the database to its previous state, right? So the technical term is rollback. That means if one transaction fails, we have to, what we have to do, we have to move the data to its previous state. So how can we achieve this one? Of course, we have to use something called as a transaction. So before you run a series of query that you want to have a atomic behavior, you have to start a transaction, right? And when all the database queries are run, you have two options, right? One is to roll back the transaction. The other option is to commit the transaction. When you roll back the transaction, the database will go back to its previous state. If you commit the transaction, all the database operations that we have done, it will be reflected into the database server. Till then, it will not actually go into the database server, right? So let us see one example, right? So I will create a table called employees, right? And I'll insert some data into, the table, right? So here I have inserted some data, right? I'll clean this one. I will say select star from employees, right? I will run this one, right? Now here what I have done is, in my workbench, I have connected to the same database, right? So here also if I run this one, I'll get the same data, right? Now, of course, why I am showing you this workbench example, I will tell you. So what I will do is, so here we have the data item, right? Now what I want to do is, say for example, I want to update employee and delete one employee, right? And to do this, I want to take help of transaction, right? So what I will do, I'll first execute this start transaction statement. That means after clicking on this start transaction, whatever query I will run, either I have to commit or I have to roll back, right? Till I don't commit, these changes will not actually go to the database server, right? So what I will do, I will start the transaction. So I'll click on execute, right? Start transaction. Now what I want to do is I want to update this. So what I'm doing, update employee, that salary equals to 45,000, where employee ID equals to 1, right? So I will execute this one, right? Now if I do a select star from employee, here you can see it is updated to 45,000. But here is the catch. Since this is in a transaction and this is the same connection that I am using, that's why it is reflected here. If I open Workbench and if I run this one, here you can see we still have 50,000, right? Because what I have done is I have started a transaction. Till I have not committed, it will not go to the database server and all other connection will still see the old value, right? Now what I want to do, I want to delete this employee ID too, right? So I will execute this one. And in this connection, if I check, the employee is deleted, right? But again, if I open this workbench and see here, see no change here still because I have not committed my transaction. Now I have two options here. Either I can roll back or I can commit. So for now, let us see what rollback will do. So now here we have two employees and here the salary is 45,000, right? Now I will do a rollback, right? A rollback. Now if I click on select star, you will see we still get back the 50,000 and the other employee that we have deleted that has also come back. Why? Because we started a transaction. Either we can roll back or we can commit. I showed you how. I showed you the rollback one, right? So if I roll back that one, the database will come to its previous state. Right here also, if you see, we still have the same data. Accurate data never changed, right? In the database server. Here the data was getting changed because it is the same connection, right? Within the same connection, it will show me the updated data, right? Now, in the same connection, why it is showing the updated data, right? Say for example, I want to delete few employees, right? But you know, delete is a very risky operation, right? It has to be very accurate. Even if by mistake I delete something wrong, I will not be able to get it back, right? So this is one example in which I can start a transaction, do a delete, check within the same connection if all the data that I actually intend to delete is deleted or something wrong data has been deleted. If everything is intended, all the data that you intend to delete is actually deleted, then you can commit the transaction. But if by mistake you have deleted some wrong data, or say for example you forgot the where condition, right? It will delete everything. But if you have actually started a transaction, after running the delete statement, you can run a select star. You will get the actually data that has been deleted within the same connection. Now, if you think you have deleted some wrong data or you have run a delete query without a where condition, you can easily do a rollback, right? This is a scenario in which transaction is very important, right? You can start a transaction, run the query, see the output. If everything is correct, do a rollback. Sorry, do a commit. Otherwise, do a rollback, right? Now we will check the example of commit, right? So I will start the transaction, right? Transaction started. I will execute this one and I will execute this one. So salary is updated to 45,000 and employee ID 2 is deleted. Now I'll execute the select star. So if you see here, this is what these two statement have done, right? Now as usual, since I have not done the commit, I still have the old data, right? Now what I will do, I will commit. As soon as I commit, I will run this one. It will actually go to the database server and update the data value, right? So here I am getting the new data that has come after this two query statement, right? Now, if I open another connection, most importantly, here if you see, I run this one. Here also, the data is now reflecting because from the other connection, I did the query and then I did a commit. So as soon as I did the commit, it went to the database server, and other connections, they will get the data, new data, right? So if you see here, it is 45 and employee ID 2 is not available with us. That means it is deleted, right? So this is the concept of transaction. So the next concept that we will see is a full text search, right? So what is a full text search? So this is basically used when you want to search a particular keyword from your column, right? Basically used in e-commerce platform in which you search for products, right? These products and its title and its description are actually stored in the database, right? So when you type something in the URL, it goes to the database and a search is performed, right? Something similar to that is given by MySQL, is called as a full text search, right? So with this full text search, what we can do is, if we have a lot of text in the database column, we can use certain keywords to search for a particular row, right? So we will take example and we will see, right? So here is example of a full text search, right? So what I'm doing is I'm trying to create a table, right? Which has a ID and it has a title and it has a content, right? It is an articles table in which there are articles and it has a title and it has some text content, right? And what I'm saying is title and content, make it as a full text columns, right? Now what will happen is, once I make this two as full text columns, I can use keywords to search content from the particular columns, right? So what I will do, I will execute this one, right? So table is created, right? Now I will insert some dummy data into this one, right? So I have some data here. I will select all and I will run this one, right? I will remove this one. I will do a select star from articles, right? I will run this one. So if you see here, it is some articles which has title of Node.js and content related to Node.js, right? So if you hover over this one, you will see some text description given on this column, right? And I have marked title and content as full text search, right? Now, what I want to do is, I want to filter out all columns in which I have RESTful, the keyword RESTful, right? Select star from articles where match what, title and content, because this is my full text search columns, against what, against a particular keyword, right? So search for RESTful keyword in title and content and give me the result, right? So I will run the query. So I have one article which has ID 2, right, in which I have the keyword RESTful in the title, right? That's why I am getting this column, right? Now, say for example, I want to use Node.js. In how many articles I have Node.js as my keyword, right? So I'll run this one. And if you see, all of them have Node.js keywords in title and content fields, right? So this is what full text search helps us in doing. It will help us in finding the content which matches a particular keyword, right? Now, this against function takes another value, like how I want to search. There are two options. One is in natural language search, one is in binary search, right? So what is a natural language search? So natural language search is like as if I'm using proper English grammar, as if I'm talking to the search box, right? As if I'm trying to create a proper English communication, right? That is what, or a natural communication, right? So, for example, I will say, so here is the example. Select star from articles where match title and column as usual, because this is the full text search columns, against, this is the natural language keyword, right? Commonly used framework for building web APIs, right? And what I'm saying in natural language mode, right? Now, natural language mode means just like how we usually communicate in our day-to-day talk, right? In natural language, right? That's what natural language means, right? So I'm saying against a particular keyword in natural language mode, right? Now, if I run this one, I'll get all the result, right? Which matches this particular keyword, right? So how this keyword matching happens? So if I have given one or more matching keywords, it will find all the rows that matches the keyword 1 as well as the row that matches keyword 2, right? So for example, here I have a keyword called testing, right? So I'll say testing, and I'll use another keyword real time, right? So I'll say real time, right? So what should be my result? This row number 3 or article number 3, and testing is on article number 5, right? So this keyword and this keyword, right? It will try to match all the rows that matches this keyword, and it will try to match all the row that matches this keyword as well as this keyword, right? So if I run this one, if you see here, real time came here, right? Because I've used the keyword real time, and testing came from this keyword testing, right? So that's how the keyword search happens, right? It's basically AND condition. So filter all rows in which I have keyword testing and keyword real, keyword time, right? Similar to natural language mode, we have Boolean mode, right? So what happens in Boolean mode? Here we cannot pass string like in natural language or like day-to-day communication. I'll show you how we will pass the keywords, right? So here what I will do, in instead of natural language mode, I will say Boolean mode, right? Here what I will do, I want to search for two keywords, right? Now what I want to say is both the keyword should exist. So what I will say, plus, I will say plus Node.js plus real real time. So what this will do, this will filter this keyword as well as this keyword, right? So if I run this one, I will get Node.js and real time, right? So a row in which we have both Node.js as well as real time, it will filter out. That is Boolean mode, right? So we will take one more example. So we have, say for example, Node.js, and I want to exclude, right? I want to exclude. That means I will say minus. I will say securing, right? So if you see here, if you check the articles, right, we have a keyword called securing, right? So what I'm saying here, give me all columns in which I have keyword Node.js, but it should not have the keyword securing, right? So if I run this one, I should not get row 4, but everything else I should get, right? So if I run this one, see, row number 4 is removed, everything else I got, right? So that's how Boolean mode will work. So for plus, if you add plus, it will include that. If you add minus, it will exclude that, right? Now we will see how we can find the relevance score. So what is the meaning of relevance? So relevance is a, so here the relevance score means for a particular given keyword, how relevant is the column definition that I have with me, right? So let us take an example for this one, right? So what I'm doing is I'm selecting ID, title and content, match title and content because these are the full text columns against keyword Node.js as relevance, right? So this against gives me the relevance score, right? So for particular keyword, say Node.js, how relevant are all the columns, right? So if I run this query, I'll get the relevance score, right? So if you see here, Node.js, here relevant score is some zeros and 5656, right? Say 5657, 5657. Here it is 3771 and 3771. So the higher is the relevance score, the better it will come in your search result, right? So here this relevance score is higher than this one. That means here the keyword Node.js is more powerful, or it occurs more number of times compared to here and here, right? It still occurs. It's not like it doesn't occur, but it occurs less or it occurs late in the string. That's why the relevance score is here greater than this last two, right? So that is the meaning of relevance score, right? So we will take one more example. Say for example, testing. If you see, keyword testing is present here and here, but if you see, we don't have testing keyword anywhere else in the title and content, right? So if I say testing, right, what do you think will be the relevance score for others, and what will be the relevance score for column for row 5, right? Let us see. So if you see relevance score, here the relevance score is 1.4, right? And others have a relevance score of 0. That means if the relevance score is 0, that means this keyword does not occur in ID 1, 2, 3, 4, but it occurs very strongly in ID 5, right? So we'll take one more example. Say for example, React, right? None of the article talks about React, right? In this table example, right? So what do you think will be relevance score here? If I run this one, if you see, all the relevance score are 0. That means this particular keyword is not relevant to any of the rows in my articles table, right? So that's what relevance score will give us. So this is the very basic overview of full text search, right?